we're on.
Welcome everyone to this Analytics and Data Oracle User Community TechCast Day on machine learning. We're just letting everyone sort of fill into the room. We'll start in a minute. Looks like people are filtering in here. I don't want to wait too long because we have so much to cover. Guys, do you think we should just start? Yeah, let's just start. Welcome everyone to this Analytics and Data Oracle User Community Machine Learning TechCast Day. Today we have a lot for you. We have, Kara, are you recording this already?
Yes, we have started recording, Charlie.
All right, super. Today we have a number of excellent instructors and experts in machine learning that are here together. We're going to try to walk you through this and get you all up and going. But before we dive into this thing, we just want to cover a few additional things. We'll introduce everyone in just a minute. But because we have 90 minutes to cover so much, I want to make sure that you have sort of the bigger picture first. So the bigger picture is today is machine learning. We're going to do the Oracle machine learning for SQL on the autonomous database with the notebooks. Afterwards, there's going to be a talk by Mark Hornick and Marcos Arancibia. We're going to do Oracle machine learning for Python. So stay tuned for that if you're interested in that. You also will want to shut down your one workshop and then reboot and go to the next workshop because there's a little bit of a setup time between those two things. Tomorrow is spatial and graph, and day 3 is going to be Analytics Plus, and some of the Analytics Plus will even include some machine learning. For those of you who want to really get right on top of things, I really recommend that you click on this link right now. And I think we have it in the chat window. Sometimes this takes as little as 3 or 4 minutes. Sometimes it may take you a half an hour. In general, it's 15, 20 minutes, and we have 15 or 20 minutes of sort of filler and explanations leading up to this. But you don't want to wait 15 minutes from now and then click. You want to click on this thing now. And Giga, Abby, Adel, Tim, you guys have already done this. Your systems are all good to go. Mine system's good to go. And hopefully the students in the audience out there are going to click on this and be good to go in short order, because we have a lot of people here. We're probably the most that I've seen. If everyone that shows up, that said they're going to show up, we'll have a large crowd on here. So get in early. This will last you, I think it's 3, maybe 4 hours. You guys correct me if you got that wrong. If I have that wrong, I think it's 4 hours. A little bit of more housekeeping kind of things. We're all volunteers. We all are part of this ever-growing Analytics and Data Oracle user community. You can chat with us in today's session by going onto Slack. And I think if you click that link, I think it will take you over here to Slack, where you can put in questions and comments over here during this session. So I think I'm in the right one here. Yep, this one right over here.
Yep,
and
I'm in there already, Charlie, and posting away.
Excellent, excellent. And so you can chat away with Abby, with Tim, with Giga. It's a great place with Adel. It's a great place for you as the audience to kind of chat away and cover these things as we're going through this. The next thing is we have a newsletter. I'm not going to chase down each of these different things, but if you click on that, we have a paperly curated newsletter that'll send you a lot of information, not only limited to Oracle, but also the whole industry. You can follow us and join us on LinkedIn. We have quite a growing community over there. You can follow us on Twitter, and we even have a Facebook page. So please check out those links. And I think they're all in the chat or the Q&A channel. By the way, if you do have questions, I think we're encouraging you to put them into the Q&A channel because it's just a little bit more organized for us. And we have different people all here monitoring those things for you. See where I want to go. I'm going to go back over here. So also, Abby's played lead on this whole thing. Abby, you want to talk about this?
Yeah, so we now do merch. So we've done merchandise from
I like this.
Yeah, like yours, Charlie, but the heat changing mug. So if you want to get into paranormal distributions, the mug changes color when you heat it up. There's a nice video on our YouTube channel and on our social media of Vlamis Consulting trying one out, which is cool. And then we have other things like phone cases, etc. And you can order them and have them sent to your house.
They make great Mother's Day gifts, and Father's Day is coming up soon, so you can do that then as well. And so anyway, a lot of fun, guys. And it's also our way of giving back to the community, but also having the community just help us just defray some of our costs along the way as well. So they're all just really low price, but in this virtual world, it's a way for us to pick up a little bit more of a donation, if you will, to cover some of our costs, which is a volunteer organization. We hardly have any costs at all, but you do have some things that do cost. So we have a growing community, as I've said many different times, and we want it to grow even more, and we want you. So these people we've all had present probably multiple times, but we want you. We want to replace those pictures with you. And so what we find is everyone knows something that other people do not know. You have some skill, some trick, something or other. And what we want you to do is submit. There's a link down at the bottom, submit your abstract. And what we do is we on Tuesdays meet as a small group and we curate these things, pick out what we think is the best talks, and we ask you to come onto our TechCast stage that's usually on Thursdays at 12 o'clock, I think. So please think about that. Our next TechCast is going to be Patrick Wheeler talking about the new autonomous database tools. There's some ETL, there's some data insights, there's a lot of very easy to use features there that are becoming quite popular, I think. So we have Patrick coming up at our next TechCast, June 3rd. So please join us for that. And by the way, all these things, including today's sessions, are all recorded. We put them out there as a Zoom recording. You can rewatch it, or you can go to YouTube where we also dual post it over there. The next TechCast days will be in the fall. We do this about every 3 months. We haven't quite figured out the details of what that will be. We'll probably just show some of the latest and coolest stuff, or get some experts on stage to show, what cool things they've done and kind of transfer some knowledge to you. But those are the dates, October 5, 6, and 7. Probably 11 to 1, something like that. But mark your calendars for that, please. Today, Abby, why don't you kick us off and tell us what we're doing today?
Okay, so today we're going to do a two-step process for detecting fraud. So as Charlie's mentioned, we're going to be working predominantly today in Oracle machine learning. It's a really cool process in which we're going to use the ADW. We're going to do machine learning. We're going to do a little bit of Apex as well. So you're going to get to see Apex front end. And then we'll discuss how it can be used with Oracle Analytics Cloud as well. So that the whole encompassing process. Really, the process starts as a very simple, you have a data set. Now, if we have a data set, that's great, but all that cool knowledge that Charlie has on fraud is stuck in Charlie's head. So how do we get that out of Charlie's head so that we know which transactions are fraudulent and which aren't? So we want to go from unsupervised learning, where we don't have any labels, to supervised learning, where we do have labels. And that's where Apex can help us by helping get that intelligence out of Charlie's head and essentially move us from unsupervised to supervised. So that's why we call it the two-step process. So we start in unsupervised, and the second step, we move to supervised.
I think it'll be a short process extracting intelligence out of my head. All right, so, and the way we do this is we, as Oracle machine learning always points out, we move the algorithms, not the data. We don't do like pretty much everybody else out there that says, I've got all this data, I need to analyze it. Well, let's move it over to, Python, R, SPSS, Watson, Data Robot, or whatever. We say data is big and it's getting bigger, right? Why don't we make the data repository, in our case, the database, smarter? So we've stem celled over 30 machine learning algorithms as native SQL functions that run inside the database, and that's what we're going to use today. So Abby and I are the two leads here, and there's a little bit about myself. Abby, so I've been at Oracle for a long time, and you can see who I am. Abby, you want to just tell us a little bit about yourself?
Yeah, sure. I'm the Chief Data Science Officer at Vertice. So I do everything that's augmented analytics, AI, machine learning. I've been in Oracle products in terms of using them for over 10 years, started out as a junior database administrator and migrated my way back into the world of data science. I do have a PhD in artificial intelligence, previously part of the NHS BSA, using Oracle machine learning to identify savings for our National Health Service here in the UK. And I've been presenting at UK OUG and also in America with these wonderful people.
And some of, like all of our other speakers, some of the previous work that Abby has done, either, at Vertice or at UK NHS, is all on the past A&D YouTubes and recordings. So search those things, you can see that. Similarly to our next speakers. So we have the pleasure of having 3 additional, we just packed the stage here with talent for you guys. And by the way, afterwards, what we've been able to do is have our volunteers, some of them, Giga and Tim and Abby have all volunteered to do a little bit of private handholding, a custom one-on-one kind of consultation with people who sort of raise their hand, or I guess we'll send you an email and we'll talk about that later on, but you'll have a limited window of time to take advantage of that. But if you want to have a follow-up, like, hey, I want to talk to an expert about my data, about my situation, we've set that up for you in advance. And 3 of our people here have volunteered to do that. So I'm going to introduce some of them. I'm going to start at the bottom. Giga is from Slovenia. And where's Giga? Giga, can you introduce yourself?
Yes, thank you, Charlie. So I'm Giga Valpot. I'm country manager for Cubics International in Slovenia, basically covering the continent of the EMEA side. I've been involved with Oracle about 25 years or so, and for the last 10 years, I'm primarily working with business analytics and focusing on machine learning and data science platforms. So basically, this is my professional life for the last couple of years. Now starting to focusing on other technologies like graph databases and things like that. And yeah, I'm Oracle since December, I guess. So that's for me.
Excellent, congratulations. Adel, you want to talk next? Introduce yourself. Edelweiss Kammerman, we have, excellent. We've worked with her for quite a bit, and introduce yourself, please.
Okay, perfect. Hello, everybody. My name is Edelweiss. Everybody call me Edo. It's easier. I have been working with Oracle technologies for more than 20 years. I'm Oracle ACE director, and I focus on data analytics, data integration, and machine learning. I have been a speaker at many conferences in US and UK, and obviously in Latin America. And it's a pleasure to be here. Thank you, Charlie.
Thank you. Next, we have Tim Vlamis, Oracle ACE Director from Kansas. Tim, you want to talk to us?
Yeah, thanks, Charlie. Hi, everyone. I'm Tim Vlamis. I joined my brother's consulting practice 14 years ago. So I've been working in this space for a while. We focus predominantly on what we call analytic warehousing, which is using the Oracle database as a warehouse for analytical processing. So we do things like machine learning, spatial and graph, multidimensional structures within the Oracle database and whatnot. We also do a lot with Oracle Analytics. So I personally specialize in data visualization as well as machine learning and kind of the data science side. So thanks for the opportunity to join today and work with you guys.
Yeah, thank you. And all the audience, please, we have all this talent. They're going to be sitting there typing answers. If you have questions about, dealing with non-normal distributions or whatever, type it in. These guys will be happy to answer your questions as you're going through here. And also Giga, Tim, and Abby are on the roster of people that you can consult with afterwards. So let's keep going. Your HOL environment, hopefully you've gotten, let's see if I have mine over here. Hopefully you've had your workshop, you've clicked on it by now. I think it's already in the chat window. Mine is ready to go. And you can get to this stage. You want to get to here. I'm assuming that some people have not quite gotten here yet. So what I'm going to do is do a little bit of filler time here, showing you what you're going to do to kind of take it a little bit more slowly. You want to click on that link. It will take you 4, 5, 10, 20 minutes for it to boot up. There's 2 different ways of doing this. You can click on the always free, the reserve the live labs, the green button where all the data and the users and everything are all loaded up for you in advance, which is very, very nice. You may run out of those use cases, those instances because of the surge of people we have here. If you already have an always free version, you may want to go there. There's just a couple of more steps or so you have to do, but if you have an always free, maybe you want to use that. If you want to go with the green button, do that. If you have your own tenancy, do that as well. In here, you're going to have the instructions. They're going to be very detailed. We'll go through that in a minute, but the first thing to do is put in your launch it, basically start up your autonomous database. And this is all you do. You submit your reservation now. I did mine about a half an hour before the event started just to make sure it'd be up and live. So do that now. There's a bunch of different workshops, by the way. If you go back here to the available workshops and you click on machine learning, you'll see, I think we've got 5, 6, or 7 ones for Oracle machine learning and other ones for other parts of machine learning from Oracle. But several of them for Oracle Machine. And the one for Python, OML for Python, will be the one that follows this session at 12:35, I think it is. So once you submit it, you reserve it. The reservation is submitted. You want to wait for it to come back and say ready to go. We'll do that in just a second. Notice on the left-hand side, when you get over to here, well, when you get to the main window, they have the workshop itself. And I did this with Anusha Pillai, and she just did a great job putting the whole thing together. There are little YouTube videos in here that describe what you're going to do. There's detailed instructions. This does not require humans here to help you walk you through this stuff. You can do all of this on your own. It's extremely well documented, but we're going to use today to give you a little bit more hand-holding and answer some questions along the way. How are we doing out there, guys, for questions? Do you have anybody that says that they're done yet, or everything on the Q&A and Slack channels are working okay so far?
Nothing on the Slack channels, Charlie. If anyone wants to reach out, then feel free.
I neither.
That is okay as well.
Okay, guys, when you do have your instances live and running, please send back saying ready to go, because we don't want to kill too much time here. So please, as quickly as you get your system up, when we get a critical mass, we'll just forge ahead. You want to log in. If you do not have an Oracle account yet, you're going to want to set one up. And I think the next screen, well, this is if I have my instance that I already have. If I don't, I can sign up. And when I sign up, it's very straightforward. I did this in about 3 minutes before one of the other sessions I did, and they'll just send you an email and you'll click on the link and you're up and going. You do not need to use a credit card. You don't need to do any kind of thing on this. Once you have that, you'll log in. They may come back and ask for a PIN for security reasons. It's very easy. Just punch it in your Droid and you're in. And so, if one of the things that we have is maybe somebody can copy and paste this into the Slack or whatever. Also, we have with marketing, they have these free cloud credits, and I think it's $300 of cloud credits and 30 days to use for even more services. This is for net new. If you already have an always free account, you're not going to get an extra $300. But if you're net new, they'll give you a certain amount. It's always free, but you also get some additional $300 worth of cloud credit, which comes in handy. So take advantage of that opportunity from the marketing guys. And while we're waiting for your systems to boot up, I don't think we're going to do this in 10 minutes. We'll do it shorter than this. We're going to briefly review some our outline. We're going to review some concepts, and then we'll get back to our hands-on lab. Abby, you want to talk about the workshop here again?
Yeah, sure. So essentially, the two-step process that we're going to do today is the first step. We're going to use Oracle Machine Learning to do unsupervised learning. So what we mean by this is essentially we have lots of transactions that essentially we don't know whether they're anomalous or not. We haven't got Charlie's intelligence saying, yeah, that's a good one, no, that's a bad one kind of thing. So essentially we want to use a one-class support vector machine to find ones that look a little bit fishy. So the Oracle Machine Learning will look at different combinations, different columns, look at the distributions, etc., and find those anomalous ones and bring them to the top. Then we're going to pass them to the Oracle Apex. And essentially, this is our screen to get the intelligence out of Charlie's head so that he can say, yeah, that's a good one. No, that's a bad one. So we're going to get that intelligence out of Charlie's head through Oracle Apex. And that then enables us to do supervised learning. So essentially, supervised learning just means we've got labeled data. So we've got Charlie's intelligence and we've labeled it and we're ready to go and build a supervised machine learning. And then finally, we can actually go either back to Apex or into Oracle Analytics Cloud to look at them through dashboards and look at how many were fraudulent, how many we predicted were fraudulent, and we can tell the business, or the wider business, the actual story. So instead of just keeping it in that little database, actually you can go and tell the world what you found.
And at the end, we're even going to show a little of this results in Oracle Analytics Cloud as well. I remember Adel in one of our conferences gave a talk where she said it's important to use the right tool for the right job. And we are not arguing that, Oracle Machine Learning's notebooks or whatever are the best thing for interactively drilling through a bunch of data. You've got OAC, and it works great for that. So we'll cover a little bit of that later on, reserved for extra points. So machine learning, Abby, again, you want to keep going?
Yeah, sure. So as we said, there's different types of Oracle Machine Learning. So Oracle have gone and taken some algorithms and pushed them down to the database level. And that's great because instead of having to ship this data somewhere else and have to think about like bandwidth and memory and storage and security, actually just leave it where it lives, leave it in the database and let the database handle it. So we have things like attribute importance, classification, regression, clustering, anomaly detection, associations. So the top ones, the top three, are essentially supervised learning. So that's when we've labeled it, i.e. we've got the intelligence out of Charlie's head. Before we get to that stage, we can use anomaly detection, which is unsupervised, to help us find patterns within the data. So other kind of common ones are clustering or association modeling. These are all kind of unsupervised. We don't have that intelligence out of Charlie's head, but actually the machine can see patterns that maybe we don't see as humans because it can handle far better depth and width of data than we can ever do as a human.
I like to use this little thing. It's from guys I used to work with a long time ago. They wrote one of the best books, Michael Berry and Gordon Linoff, in my opinion. And they use this simple little diagram to try and show what machine learning is and how it works. And imagine taking income and customer months to just two variables, x of I, x of 1 and x2, to try and make a prediction as to whether or not you're a churner or a loyal customer. Something we have a lot of people who buy a Tesla car, people who do not buy a Tesla car, things like that. And if you just fit a straight line through that, not so good, right? You put a little curvature, maybe some cubic or quadratic terms, maybe pick up a few more of the blue guys, separate the red guys a little bit better. But a machine learning algorithm would cut through this thing like butter, and it just iterates through everything. This is a particularly, the particular depiction here is that of a decision tree that finds these sort of curves in the data. It iterates at every single junction point here until it finds, oh, there's a significant reduction of entropy here if I put a split node right there. And the nice thing about the decision tree is that it also provides human readable rules. Now we also have something called prediction details that approximate something very much like this, regardless of what algorithm you're using. It's called prediction details. And I think we show that later on in here, but it's nice because you can explain what's going on there. You found pockets, and it's able to, you can explain it. But we're looking for fraud, right? So fraud is a lot harder. You have no examples or very few examples of what you're looking for. So how do you fit a line through that, right? I should have drawn it the other way, but how do you fit a line through that? It doesn't fit so well. So what do you do here? Well, Abby, you want to do this one or me?
I'll let you do it, but for anyone from the UK, he's going to call this character slightly different.
Yeah. I think we call him, you guys call him Wally, we call him Waldo, I guess. I don't know where he originally came from, but this crazy character is in a lot of children's books. And I think this kind of works a little bit for kind of showing you what's going on. So Waldo's usually this crazy character. He's on a beach, he's in a supermarket, he's in with a lot of data, if you will, and you're trying to find this anomaly, this kind of crazy guy. So we're going to do like what the little children's books do. We're going to use our brain, we're going to look at an image, and we're going to give you 10 seconds and see if you can find him. Nope, time's up. 10 seconds went by fast, and there he is. But how did we find him? We kind of use our brain, go sifting through here, looking for things that kind of stand out. Like maybe it's almost a classification problem. You could think of it if I'm looking for stripes or certain things, but I'm also looking for things that stand out. So it's sort of maybe a dual approach. But how do you sift through large amounts of data to do that and find that? That's where we're going to let the machine learning algorithms do that for us. And it's a little bit like, you guys have Big Bird over there? You do, don't you? Yeah, okay. So Big Bird, when my kids were growing up, had this little song, one of these things is not like the others, one doesn't belong, you can tell me which one it is. And he eventually has this little song, if you play the link in here, he'll point out this bowl of bird seeds bigger than the other ones, and that's why it's different. And so that's what we're doing in anomaly detection. Abby, maybe you want to talk about this?
Yeah, so essentially you can draw lots of different distributions over the data, and you're looking for a single attribute or that seems okay, but actually it's combinations of that looks different, and that's what brings it to the top. So it's slicing the data in so many different ways that maybe as humans we just simply can't do, Charlie.
Yeah, and any one thing might stand out, but is one with the fact that you're 6 feet 9 inches that unusual? But if you're 6 feet 9 inches and you weigh 65 pounds, well, that's sort of unusual, right? And so what we do here is we train on normal records, and we get this understanding of what we think are normal. Now, if they're not very normal, we have a bad model, but we trade on what we believe to be as, you know, as good of example representation of what we think are, or at least don't know that there's any problems in there. And we take that model of normality or normalcy and apply it to new records. This is, I still didn't get the formatting right on a couple of the things here, but this is my my own expenditures. And these expenses, there's some fraud in here, but I don't know if you see it. These expenses were actually valid. It was a business trip on Oracle. But if you look a little bit further, suddenly I have all these gas station things. And if you look at the geolocation data for this, it was a part of Connecticut Western Connecticut that I like rarely go to. You also notice all these records that are the exact same amount, which is kind of stands out a little bit. And if you're using your Spidey sense brain with all your domain experience, you might be saying, oh, that's a little unusual. Maybe I want to count how many records end in 00, or how many, do a count distinct. Or if I have 15 submissions, how many are different, or are they all the same? I know guys that do like internet, you know, tax fraud, that do that for the IP address you submit in on and such. They all come in pairs of 2 minutes apart. That's a little unusual. And if you look at the SQL windowing functions, like a moving range of time, you might see that my amount of purchases at gas stations suddenly shot up a fair amount. Suddenly I'm doing all this. So these are the kind of things you want to think about. And in our example, we'll show you a little bit of that, but this is an area that I think is rich in what you can do here. And I know Tim and Adel and Giga, you guys have done a lot of work with developing engineered features and things like that. Anyone of you guys want to comment a little bit about the importance of doing this?
Yeah, so enriching your data set with calculations and known anomaly like pairs, those kinds of things really helps in terms of developing good models. So this is an important part of machine learning processes, you know, pulling out the important features in the data set and revealing them through, you know, new calculations and whatnot.
Super. Yeah, we call them like engineered features. So I always like this quote that says, if you're going to think about a problem, really think about it hard. So everything that Tim just said about, you know, count, you know, how many distincts you have, do you know, anything that you would say, not the data that I have, but the data I wish I had to try and find the fraud. That's, I think, what a lot of it is. And that's where the expertise of a machine learning consultant who's done this a few times and knows kind of how to think creatively in that way, I think comes in really handy. So anyway, quick details, and we'll get launched into the hands-on lab. Oracle Machine Learning is just part of the database. Today, we're going to be doing the Oracle Machine Learning for SQL. It's a free feature of the database. So I always kind of say, you know, it's a public service announcement that everything we're talking about today is free. But depending on what you're doing here, you have, if you use R, which is on-prem, you use OML for R. The talk that's going to follow this is going to be OML for Python, which is available on the Autonomous database currently, and will be moved down to on-prem as quickly as we can get it there. You have the Oracle Data Miner drag and drop GUI that comes with SQL Developer. That's very mature. People use that a lot on-prem. We're going to the cloud and we're using the notebooks. So we're also going to use the AutoML User Interface just briefly. So that's the product. And if you contrast what Oracle does here versus other sort of fragmented, multi-fragmented database platforms and such, it just seemed to me, it makes a lot more sense, right? It's just this converged database that one platform can do multiple things: JSON data, unstructured data, Python, R, blockchain, aggregations, unstructured data. It's just a simpler architecture. So we're going to kind of show you how you do that. We're going to use today, what are we using today, Abby? We're using one class support vector machine. And I think we're using 2 or 3 of the different 4 maybe of the classification techniques. We're also going to do the AutoML. And the nice thing about this is all of the algorithms that we're doing can also do transactional data, unstructured data, graph, spatial data. I think Giga was saying something about doing graph data. If you had, and there's in the graph session tomorrow, they're going to talk more about this. But if you had relationships with different people on, say, a bad guy list or something, pull that in. Giga, you want to talk about that at all?
Actually, you just nailed the anomalies, you know, with these bad guys things. Yes, true.
Yeah, it's a fun area for a data analyst, I think, to play. So we're going to go into the notebooks. That's what we're doing today. There are 54 examples. We're going to use the OML for SQL primarily. The OML for Pi just came out. This is OML for, it's the same notebook, right? But I just wanted to highlight a few more Python-oriented paragraphs. To get you have a little bit more graphics, you can use your favorite Python language. And when you do the correlate here, it's pushing down to the in-database correlation function, or when you do a decision tree or when you do the box plot, it's using the transparency layer to allow you to speak your native tongue of Python, or in the future, your native tongue of R, or also use GUI that we'll show you in a minute. But it pushes it all down to the in-database functions. One of the things we're also going to show in today's session is the AutoML User Interface. It has under the hood the AutoML functions, the auto algorithm selection, adaptive sampling, auto feature selection, that are all accessible today via the OML for Python syntax, but it pushes the functions down into the database for in-database execution. We wrap this and put a user interface on top of it as well, called the AutoML User Interface, which can also generate models. It can generate REST endpoints for deploying the model and so on. So we'll just touch upon this a little bit and get you to drive the AutoML User Interface. It's a relatively new feature, so it's something that's not real well it's not documented in the current live labs, but you're going to get the chance to do that today. Now, when you get into the notebooks, and we'll go to the live thing in a second, you're going to get these example notebooks. You can open one up. Under the hood, what that's going to be doing is running a DBMS data mining create model. This is the syntax. That's all it really is. So, all this, magic about, you got to know, you have a PhD in machine learning and know how to speak 12 different languages and all that kind of stuff. If you speak SQL and you know your domain, this is kind of what we're doing under the hood. And we put a GUI on this or example code in the notebooks. But that's all it really is. And once that model, the claims model, has been built, you can score it like that. It's just a SQL function. So I think we get to go on to our workshop now. You guys ready? Okay, so my workshop is already done. I'm going to go over here to live, and I am going to show you where I got to. So I requested it. Guys, has anybody sent back any feedback that they are live and in here yet? Have the audience been able to say ready to go? Hopefully, yes. Somebody?
Yeah, 2 or 3 people say that they are ready to go.
Okay, is there any reporting of any problems with anything booting up or anything so far?
Not yet.
Okay, good, great. Let's get on with it. So I launched the workshop. I already clicked on it, so it's right here. So I launched on this. Here you are. Now, I always tend to go to my PowerPoint and all that, and sometimes forget that there are all these great instructions here, because I kind of think I know what these instructions are. But what I want you to do is click on all these instructions and notice that in here, there are little embedded videos in here. There are steps for everything you're going to do. So we're going to follow along these steps, and we're going to do it a little bit live right now. So I'm going to go into here, go to the top of this, I guess, launch workshop. Is this the one? Not that one. I'm going to go back over to here, launch my workshop, and here I am. So hopefully you can get to here. You just launch it. Now, what you're going to want to do is copy this password. It's called the initial password. Just click on that. Copy it. It looks like it's laying out a little bit weird here for me right now. Hopefully this is going to work. And then you want to launch the console, but the instructions are down here, and it tells you exactly what you're going to do. So we're going to launch the console. We're going to see if that correctly copy and pasted what I was going to do there. And it looks like it did. So let's hope that did copy and paste. Now, here's the other thing you need to remember. Remember these little numbers. Every one of you guys can have your own unique live lab assigned number. You're all getting your own little sandbox to play in for the next 4 hours. And so mine's 5179. I'll do my best to remember that. Now, when you log in, the first thing it says is change your password. Now, I got this trick from Tom McGinn, who said just change it back to the original one, because you'll never forget it. If you lose it, you just go back over to here, copy and paste it again. And you're only doing it for 4 hours. So if you want to change it to something else, go for it, but you don't have to. So I'm going to change that password, and now I am in the autonomous database, or in the console, the initial console. And when I come over here, this keeps on changing around a little bit. I'm not sure the live lab or my PowerPoints match this exactly, because it just keeps on sort of evolving just a little bit, but it's probably 90–95% the same. You go to this little hamburger menu over here on the left, and over here you have a bunch. Do not click on this. That's going to take you in other things outside of the database. It's a little bit misleading, but don't go there. As a matter of fact, go to the databases. And if you go to the databases, we're going to want to click on the autonomous data warehouse. Okay, ADW, autonomous data warehouse. Now, do not click on create autonomous database. It's already been done for you. So if you do that, you'll go down a curve and get kind of in the wrong spot. What you want to do is go over here and find your right compartment. So there's all these different compartments that have been created for these live labs to give your own special instances. And I think mine was 5179, something like that, I think. I can't remember it, so I'm going to go back over here, 5179, and I go back over to, where is it? Right here, 5179, right here. So when I click on that, notice I already have an autonomous database, so I'm all set and ready to go. Hopefully you could do doing the exact same thing and you're following along. I click on
Charlie,
that. Yeah.
Let's do that. Just show people where that number is again. Just nice and slow, just so people can see what that number is.
If you go to your main console, it's right here, the one I've been assigned. And if I go back over to here, I think I can just go backwards, right? If I go back over to here, autonomous database, and I'm already in the compartment, but it'll start out here with you up at the top at root. This is where everybody screws up, so this is good. Thanks for bringing us back there. Everyone misses on this. So you just want to find the compartment, and there are all these live labs that have been, people all over the planet are doing this thing right now. So you want to scroll down here. I don't know if I can just type down. I guess I can't speed dial type, can I? So I want to go in and find 5179. There's up to 5178. I don't know what would happen if I wanted somebody else's one. I guess I just couldn't get in. 5179. There's mine.
179.
Oh yeah. See, 51.
The good thing is that you cannot, enter into the
What happens if you go into another one? It just doesn't let you in.
It seems like you don't have access for it.
Yeah. Okay. All right. I guess I actually never clicked on the wrong thing. So that's it. And we're going to click on this, and we are in. Now notice also back in the instructions back over here, it's telling you what to do. So we've done all this stuff here. We've opened the, we've gone to the next stage over here, and we are launching the workshop. It gives us these instructions. We've picked our right compartment, and there we go. And when I get to the bottom of this, you can proceed to the next tab. There's another little video here that you can watch, and it's going to walk you through the next steps. So we're going to go to Tools. We're going to go to ML User Administration, and on down the line. Now, in here, you are going to want to know the password here. I think there's a different one. Your admin password is the password you copied from the launch page. So good. Some of these things have it slightly different. So we're going to come in here and go to Tools. Go to, and by the way, hopefully in the instructions that have two different windows, have one monitor here, another one monitor over there. That helps a lot. I'm working from home. I actually only have the one monitor here, but if you have two, it makes it a lot easier. So I'm logging with the Oracle Database Administrator credentials, right? So I'm not coming in as OML user, I'm coming as admin. And my user credentials are what? They're the ones that I have in my copy and paste thing right there. So this is where a lot of people mess up on this one as well. So make sure it's admin and you log in like that. We get in. I'm not going to bother updating this thing. Now, if you're using the green button, you already have an Oracle machine learning user set up over here. Really nice. And the data has already been loaded. In fact, the SQL developer part over here has already been loaded for you. So it makes it really kind of simple. Now, if I remember the instructions correctly, it says now click on that. And we could create a whole new another user because we're in here as admin, right? So I can create another user. I could add Adel as another Adel 2 or whatever and add her, but I don't need to. I've already got what I need to get through the live lab here. And I'm going to click on home. So now I'm going to come in and log in as OML user. And I think my password here, guys, is what? I think it's AABB, that one, right?
Yeah.
Let's go look at our instructions here. I think it's down OML user, and there it is right there. See that? My favorite password I stole from Tammy Bednar. And very easy to remember. I come back over here and I am logging in with that A, capital A, small bb, small cc, and log in. And if I'm lucky, we're in. Okay, now here's AutoML. We're going to come back to that in a second. But here's the home. There's no recent notebooks. There's nothing else going on here. I can create a new notebook, but there's nothing here. But so what I'm going to do is go back to, no, I'm just going to take you right into here. Let's go look at the examples. And we're probably going to modify this a little bit so you don't have to do this one at a time, but there's 54 examples down here. Now I'm going to go down to here and take this one right here and what I'm gonna do is you can open this up, it's read only. I'm gonna save you a step. Don't click on it, just highlight it. And then come in here and say, create a notebook. Now, one thing we're probably gonna add as a feature here is OML for SQL example classification. I'm gonna call this classification 3 or something. So I'm gonna give it some sort of name from examples. It's gonna go into my own project use workspace here, which I can share that workspace with others, all the people in all my colleagues here. We can all share this together. And it's created a copy of this. Now I may just want to go in here and say, oh, here's association rules. There's a recommendation engine. There's little tags on here. You can search the tags and find out. If I go up here and search by tags, you can see, you can find other things in here as well. Sort by name, sort by tag, sort by whatever. And there are other ones down here. I might want to take the anomaly detection, but I'm not going to bother right now. We're just going to keep right on going. So hopefully you've done that. And if you come back over here to notebooks or back to your home page and go to notebooks, then you have this notebook here. And if you click on this, it will take a few seconds or maybe a minute sometimes to load up, because what's doing is it's loading up a VM for running the Zeppelin engine to fire up the notebook that's mounted on the autonomous database. While we're waiting for this, you guys anybody have any comments or advice on this? All right. Pretty straightforward, right? We just opened it up. Now in here, you have this little gear thing that says, what are your interpreter bindings? So these are the speed, how many lanes of the communication channel to the database that you want to use. And these are already set up for you. If you have a lot of users, you may want to set a lot of them down to low. And it's based also on user privs on the back end of what data and such you can get access to. But here's a whole notebook for doing something. We're going to walk through our own in a minute, but I'm just going to show you one of my own favorite little tricks here. If I've got this whole thing, and by the way, you can change the width of these things. You can create a paragraph, you can clone a paragraph, you can use markdown language. At the beginning of each paragraph, the default is going to be SQL, unless you say, no, I want to write some, I want to use PL SQL, so create script, or %Python to do something in Python, or markdown language. So these are all just example ones. I'm just going to start this guy running just for the heck of it, and then we're going to move on. And what this does is it launches the whole sequence of things in the notebook. Now, I'm going to go back to the PowerPoint first, make sure we've covered everything. So we've done that. Reservation is live. You've already copied and pasted your thing. This is sort of reinforcement of what hopefully you've done. If you've missed anything, we'll cover it right here. You're pasting your things in here. You're clicking on the hamburger. You're clicking on the autonomous data warehouse. You're picking your compartment. You're launching your autonomous database and going into tools. You log in as admin. You highlight the user, AABB. So you see that username here. You go to the home page. We're going to click on the examples. You can use these at will. You can copy and you know, that's a lot of the guys that I work with just basically use the examples as training wheels and then modify them. They really are a lot of good useful examples. We're going to use these two ones today: classification and anomaly detection. We created a notebook. It created our workspace, and there it is. So same thing I just showed you. There's a notebook. There are also some, we ran all paragraphs. You can watch that. We're going to go into our own one. There are other ones out there like the association rules, and now we're into our unsupervised claiming fraud one. So here we are going to go back to the instructions, and we are back here. I think import the notebook. So if I go over to here, it's going to say right about here, what's that? Step lab 1, step 2. And what you want to do is download these two files. They're already set up for you. The data is already in the database, so it's sort of straightforward. And what we're going to do is come back over to our instance and go back here to where we're going to go back to notebooks. And we're going to click on import. And the notebooks are the ones I just downloaded here. Now here's where you can actually multi-select here, okay? So I'm going to pick both of these two guys, import them, and here they are. Abby, once this open up, do you want to talk through the anomaly detection one first?
Yeah, can do.
All right, here it is. I'm going to open up the unsupervised learning one first. And just tell me where you want me to click if you want me to click anywhere special.
Sure. Okay. So little things like, so I've been using these notebook environments for a while now. So it's a Zeppelin-based environment. If you're used to using things like Jupyter Notebook or Zeppelin notebooks, you'll kind of be familiar with this. Charlie, could you just expand out the auto insurance claim frauds where it's explaining what we're going to do? So little top tips, there are 3 kind of things that you need to know, and that's percentage MD is marked down. So this is where you can put notes in your Zeppelin notebook. So you can use markdown language to essentially create notes that, so if I'd done some analysis and I was passing it over to Adel, she'd know what I've done, why I've done it, what I've observed, and she'd be able to see my notes. So it's a really nice way to be collaborative within your team. So that's the first one that you need to be aware of. The next one, if you just scroll down a little bit, Charlie, is percentage SQL. So this is your standard SQL to the database. So this is where, you know, we're talking to Tim about like looking at how you can enrich your data. So selecting data from tables. This is where you can use some cool aggregation features within the SQL. There's windowing, there's averages, min, max. I think someone once told me that there's like over 200 different analytical functions just built into the database. So this is where you can really kind of explore them and start to add and enrich your data. And I can see Tim nodding away there going, yep, definitely, this is where you want to get into that. So use your percentage SQL to really get to know your data, explore it. And the cool thing about the Zeppelin notebooks then is you can essentially create a picture. And as everyone knows, you know, you end up, a picture tells 1,000 words. So if Charlie, on that first graph, if we just change it back to table format, just so everyone can see it. So originally, if we just do normal percentage SQL, we'd get it back in a table. But as you saw, if we can then put it into a bar chart, yeah, that's it. So we're doing select star from the claimed 0 table. If we click onto the bar chart now, we can put a picture on that. So here we've got the days of the week, and it looks like we've got males and females. So if Charlie clicks on the settings part, we can actually see all of the columns we've pulled back in the table and drag them down. So we've got days of the week as the columns. He's changing it to vehicle category. I'm starting to explore the data. This is where, you know, Tim was talking about enriching. By exploring the data first, we're getting a feel for it and we're understanding it. And this might, as domain experts, we might say, hey, actually, you know what? We need to do that windowing. We need to look, you know, in the last 3 days, how much have I spent? Or in the last month, how much have I spent? And you can really get quite clever with some of your SQL. So you might want to add context such as, you know, what's the average you spend in a month, and partition by grocery shopping or partition by, you know, gas station. And that gives the algorithms context to the data or enrichment. So you can see here that we're doing lots of different ones. And you can get as complex or simple in this as you want. You can go pie charts, you know, line charts if you've got time series data, scatter charts. Really, the world's your oyster. And it's brilliant because we're still inside the database. We've not gone anywhere. We're just exploring the data and we've stayed inside the database, which is super cool.
And one of my favorite ones, this little sample one, just, you know, instead of trying to throw all the data up there, just take a representative sample. I'm gonna scroll down a little bit. Go ahead.
Yeah, I was just about to say, like, sampling data is really cool. And the sample feature in the Oracle system enables it to be a distributed sample as well, rather than, you know, getting caught out, especially in the fraud world, you know, where we tend to be looking at less than 1% of transactions. I've been working in fraud world now for more than 8 years, and everything from health fraud right through to tier 1 banks, global 5 kind of bank, and having to do kind of transaction monitoring and things like that. So yeah, look at things like the sample feature, especially if you've got billions of rows, just to bring it down to a more manageable data set.
So we got a lot of cool graphs. Here's our modeling.
Yeah.
You want to talk about that?
Yeah, so once you've explored your data, let's get into the modeling. And as Charlie said, essentially, it's a bit like having a menu at a restaurant. The menu's laid out the same way. You're just going to pick the things you want and plug it into essentially the same PL SQL. So this is the third part of a Zeppelin notebook you need to know. So you've got percentage MD for giving notes to each other. You've got percentage SQL for exploring the data. and then you've got percentage script. Percentage script is PL SQL, essentially. So you can declare a varchar here, and essentially, as all good data scientists, we're going to drop our previous runs of this model and what our data set was. So we're going to drop those off. And then we're going to do 2 steps. So the first step is we're going to create a table that is essentially the settings. So if we think of this as the menu, what are we going to put into our dish? So, you know, is it spaghetti and tomatoes? Is it, you know, just spaghetti and pesto? What are you going to put into your menu? So here we're going to use the algo support vector machine, and we're going to say prep auto on. So if there's any nulls or anything funny in the data, the database is going to handle it for us. And then the last line, we're going to just say, yeah, once that's created, let me know by saying it's been created. The second step is actually the machine learning. So essentially the chef is taking what you've ordered and building the model for you. In this case, the machine learning algorithms or the database is building the models for us. So the model name is going to be called claims model. The function it's a classification function. The table that we're going to use is the claim 0 table. The case ID is like the unique column of the data. So in this case, it's the policy number. If you're working in transactions, it might be transaction ID. Target column name, and you can see that's null. Remember, we're in unsupervised. So at this stage, we haven't got the intelligence out of Charlie's head. So we've got no target column to learn from. So it's unsupervised. And we're going to use that claims settings table that we just created. So to run that, you press the play button in the top right-hand side of the little window function.
You know what I'm going to do, Abby, as you're talking, I'm just going to launch the whole thing like I did before. Run it all so we can kind of see it go by, and I'm going to get you back down to where you just were. So this, notice it gives you the time, how long, 2 seconds to run the little markdown language and 0 seconds and so on. So I'm going to get you back to where you just were here. We just set this thing up. It'll probably run right as we're sitting here talking here. 4 seconds to run this the first time. And if you run it repeatedly, it goes even faster or whatever. But there it is, just built your model in what, 2 seconds. And then we'll take you down a little bit further here, Abby. Okay.
Sure.
Hey, Abby, can I make a quick comment about the auto data prep setting, which I think is actually pretty important, because they built in different defaults for preparing the data based on the algorithm. This is one of the best features in Oracle machine learning. And so if you're worried about null treatment, if you're worried about a lot of things that we have to do in when we're doing machine learning in a lot of environments, just to get ready to build a model, this does a lot of it for you, and it cuts out a huge amount of time. And I just want to call it out as something that's easy to miss when you're starting out. And you can dive into the documentation to see what those particular settings are for auto data prep, if it's doing, you know, the average, the mean, and replacing a null with a mean or something like that. But that's the type of thing it's doing. Anyway, sorry to interrupt.
You know, actually, I was going to say, and to take that further, when the algorithms run, they have embedded auto data prep to normalize all the variables on the way in and unnormalize them on the way back out, things like that as well. Good point. Abby, where are we now?
Okay, so the models ran, and this is an unsupervised model. So essentially, we are asking it to find us the kind of most anomalous, i.e. the one that's least fitting. So I'm trying to find Waldo or Wally, and I'm looking the least like the rest of the world. So here it's pulled out that first line, that policy number 14485, and it says it's 71.35% anomalous, or what we've termed percentage fraud. And you can see on the right-hand side, we've ranked them. So we're ordering them to the most anomalous at the top and least anomalous going down. So you can see very quickly that it's found the transactions that are kind of maybe not quite stacking up, a little bit suspicious, probably need a bit of investigation. So if we go down, we can then even explore this further. We can start looking at, you know, why is it pulled it out as anomalous? Have a look at the data a bit more, explore it again. So here we can see 31 to 35 have more kind of policies in there. So is that why it's pulling it out? And then if we look at it when we order it the other way, so we can definitely see there is more policies in that 31 to 35 bracket. So we can use this to really kind of explore our kind of transactions that it's pulled out as anomalous. But then what we can also do is show the top 5 most suspicious customers. So, you know, we can then sort of use that where rank is less than or equal to 5 and just pull out the top 5 transactions or policy numbers that have caught the machine's attention.
This one's kind of weird, Abby. One vehicle, huh? This woman got into an accident, one vehicle. That's
Yeah.
weird. No witnesses. And we're only showing some of the data, not all the variables.
Exactly. So, you know, this starts to kind of, if you're an investigator of insurance fraud, you're probably saying, well, how on earth has someone got into an accident? There's only their vehicle and nobody actually witnessed it. Okay, so, you know, you start to see unusual things and you start to kind of question it and say, okay, yeah, I can see why the machine sort of pulled that one out. So essentially, you can keep exploring and adding more columns and really start to do this. But essentially what we want to do is, Charlie's a really cool guy. He knows this world really well, and we're going to get that intelligence out of his head. Now, if we think of this as a company, we might have hundreds, thousands, millions, billions of transactions. And poor Charlie can't sit there and label billions of transactions. Charlie, that would take you too long, wouldn't it?
Nah, I don't have enough time.
Exactly. So what we want to do is use that unsupervised learning to bring the ones that we think are anomalous to the top so that we get those in front of Charlie sooner. And he's, you know, we're using his resource as effectively as possible. So in this step, essentially, we're creating a table called suspicious claims where we're putting in and we're ordering it. Well, we're pushing through the information about how anomalous we think it is. Prediction details, so, you know, why was it, you know, anomalous, and creating this suspicious claims table. And you can see at the last bit on the percentage SQL, we're just kind of selecting it and checking that that table's been created. And essentially that's the table we're going to put into Apex to create a front screen for Charlie to look at.
Sorry, I just scrolled here. This guy right here, suspicious claims. All right, so we're ready to go to part 2, and we have 35 minutes left. So we got to move faster and solve our crime problems here. So I am going to take a shortcut here, and I'm going to go directly to my instance of Oracle Application Express rather than trying to do it from the live lab. Hopefully you're kind of following along, and if you keep on following along these instructions here, it's going to say use it in an application, run the Apex application. Well, I guess maybe I can do this thing. So where do I go to? I go up here to Oracle Apex. So if I go back over to here and go here, I go to Oracle Apex. I got my other one over here on backup in case I forget my password or something over here. Oracle Apex, it's already loaded for you in the application. And here's the part I was going to always mess up on. What is the user? It is going to be OML app, OML user. And I think the password is still our favorite AABBCC. Okay, so here we go. So we can do this OML app. And this really helps a lot if you got 2 windows over here. OML app, OML user. Is that our password as our username, guys? Or is it OML Apex?
OML user.
OML user, perfect, thank you. And then our password is our favorite AA, small capital AA, small BB, small CC, 1, 2, 3, 4, 5, 6. It fits all the security requirements. And I'm not going to save that. Come in here, the Oracle OML user. I'm going to ask you to refer to the instructions. I'm just going to kind of go to where I know this thing is. And I have this application that's already been run. It's already been built. And by the way, if you guys get your COVID vaccines, there's a little app called vSafe that you'll all be using. It's built with the same technology, Oracle Apex. It's a very simple, low code is what they call application. And OML user. And we're going to log into this one. It's sort of a low code thing. That's AABBCC 1, 2, 3, 4, 5, 6. And it's a nice little application with a login and change password. What do I want to do this? AABBCC 1, 2, 3, 4, 5, 6. Can I change this to the same one? AABBCC 1, 2, 3, 4, 5, 6.
It won't work. Charlie, change
7. I'll go to 7. AABBCC 1, 2, 3, 4, 5, 6, 7. Okay, that's why I always like to skip these password crazy things here. Uh-oh, enter password. Am I doing that wrong, guys? I didn't want to change my password. I just want to run this thing. OML user. I got to back up, guys, if this doesn't work. AABBCC 1, 2, 3, 4, 5, 6. Do I have to change my password? Password that must be changed. Current password is AABBCC 1, 2, 3, 4, 5, 6. AABBCC 1, 2, 3, 4, 5, 7. I'll just make it, see if that works. AABBCC 1, 2, 3, 4, 5, 7. See if that works. If not, we'll go to my backup. No thanks. Anybody, a password does not conform to the site's precedents. Here's what I'm doing. I'm going to save us some time. I've got my own instance. Make up your own password and get in there hopefully a little bit more successfully than I did. If Tim or Adel or Giga, you got any suggestions of what we're doing, what I'm doing wrong there, speak up, because I always mess up on passwords. It's not adhering. So what, I have to have a unique character in there, like a $ sign or something, I think.
I think you, sorry, Charlie, you have to change a little bit more than just one digit.
Oh, really? Okay. So
yeah.
I put in the first.
Put
well, let's just skip over
1,
that.
2, 3, 3 at the end, and that will be okay.
Say that again. I'm sorry. AABBCC 1, 2, 3, 4, 5, 6. What do you want the password to be?
AABBCC and then 1, 1, 2, 2, 3, 3, and it will work.
Okay. AABBCC 1, 1, 2, 2, 3, 3. You're a genius. Thank you. OML user. And then the password is now AABBCC 1, 1, 2, 2, 3, 3. I always hit speed bumps on passwords and mess up. All right, so here we are, guys, and hopefully you've gotten to the same place. If you are having struggles, or if you get in, please, any kind of feedback you can put in here. So Abby's kind of made me some sort of domain expert here about insurance claims, and I'm gonna try and do my best to live up to that. I also like to kind of knock this guy down just a little bit so you can see him just a little bit. You may want to do that. But this is nice little application. We're not going to show you how to build the application. Trust me, it's not that hard. I even have some fingerprints on having done some of this myself. Sometimes get a little bit of help, but I think I can do it pretty much all by myself if I had to. And that's saying something, right? So I have here these little graphics that come up here, and notice these little faceted searches that kind of happen automatically from using the Apex application. If you set it up as you set up the thing as you define % fraud vehicle category, if you take a lot of the defaults and just say faceted search, you get this kind of behavior here. Comes for free. And notice over here, Abby was talking, I think, about the prediction details or the reasons why. I think we just touched upon that. I don't think I scrolled all the way to the right to show you that. But these reasons come out of the Oracle machine learning model. So it gives me, as a domain expert here, a little bit of information here. It says, okay, the #1 variable is the address change. It was 1 year. Oh, that's a little bit interesting. And I have my % fraud over here, which I can sort. So I have a nice little sort of easy user interface over here to kind of play around with things. And I can also say, well, I just want to see the top 2 most suspicious ones. And there's that same 14485 woman, right? She's got a sport car, a Honda, 2 to 3 years since address change. She's a female, collision. Let's go check this thing out. So so this is a great way to just kind of sift through it, but we're going to take this a little bit further. Remember, this is the 2-part way of doing it. It's taking the algorithms to kind of serve up the ones we think are suspicious. The domain expert, I guess me in this case, which is scary, comes in here and looks at these reports. Now, this is what the algorithm has assigned me to look at. I have, in fact, there's the very first one, fraud found, and it says it already is declared as fraud. Maybe I investigate this and I say, vehicle price more than $69,000. I'm going to say, yes, that is fraud. I'm going to curate that and say that is fraud. That just seems a Honda worth that much. I'm going to take this other guy over here, row #1 or policy #1 right over here. And I have all the information that's been served up to me. And I'm going to use this little form as well here. And I'm going to say, another female, single, 1 year for the address change, more than 30 days to fill it out. Here's another expensive car. What is going on here? That's a pretty expensive Honda, right? Somehow this just seems fishy to me. So I'm going to label this data and say that's a yes. I'm going to apply this. And now if I go through here and sort these guys, doing the right way, there's number one. Notice I've labeled the data. I've overridden what was in the database, and I've said, no, this is fraudulent. So that's kind of clever, right? The algorithm served up a bunch of things. I, as a domain expert, kind of take an afternoon, sift through these things, use my domain expertise, and off I go. Giga, Tim, Abel, anybody want to comment on this section right here? Abby?
I'm busy.
So I would just say this is also for finding where we have a known pattern, right? So we're going to train Oracle machine learning to recognize a known or a pattern we're aware of. And so these are people committing fraud that are naive, if you will, because they're going to fall into the same type of behavior. This is not for finding people that are evolving their strategies when they're committing fraud.
Well, it could be. I mean, as we search it down, but
Yeah.
here we've sort of we've labeled them as some are yes, some are no. So that kind of sets us up for part 2, where we're going to come back over here, and now we have that other notebook that we did before. So we're going to go back to our notebooks, and we have our supervised learning notebook, and it's the same thing, but it's a little bit different. Abby, you want to walk us through this, or you okay with that?
Yep, no worries. So same thing. Your notebook has still got the percentage MD, percentage SQL for exploring the data, and then percentage script for doing your actual modeling. So again, we can put our notes at the top. Charlie's going to run everything in here. So again, now we've got them labeled. So we've got the intelligence out of Charlie's head through the Apex application. We're now using the claims table, and we can now actually start looking at, how many are fraudulent and how many aren't. So we can have the same graphs as last time, but now we can start to even do, change it so that you group by fraud or not fraud. So essentially the label, the flag that we've been doing through the Apex.
Yeah, so this should be probably labeled a little bit better, but it's fraud yes or fraud no. So that's what we did over here.
Yeah.
It's still waiting to get, it's still running through the whole thing, so it's not giving me the attention to open that up just yet. But this is, what are we seeing over here? There's 50% of the 36 to 40 people are in fact fraud. I guess 50% over here, but this guy is even more than 50% over here, right? It looks like.
Yeah, so it starts to give you a feel of where potentially the fraud is, and like you say, it's the observation of the patterns of data. And so here we are in terms of splitting the data we've got. So we've got the information from Charlie's head. And the first thing all good data scientists do is create a training set and a test set. So we use the sample 60, the seed one. Seed one enables us to be reproducible in the future. So it reproduces the sampling technique it's used. And then we use the minus function, and we say, if it's not in that 60%, put it in the other side, so the other 40% into the test set. So we end up creating a claims train data and a claims test data. Now we're on to essentially creating the model. And like I said, it's just a menu. So you're just going to go and select slightly different things this time. So this time we're using the we're doing attribute importance. Same thing. So it's still collecting it off the menu. So we're doing attribute importance as the mining function. We're using the claims table. The policy number is still the unique case ID, but really important this time is the target column name isn't null. It's not unsupervised, it's supervised. So we say fraud found, and that's the column where we've been capturing Charlie's knowledge. So once you've done that, you can then essentially get out the attribute names, so the column names, and its importance value, and it's ranked as well. So we can see the policy base, the vehicle category, and fault all tend to be highly kind of correlated and support the kind of fraud found column. So that's really interesting, and it gives you insight onto how our machine learning models are going to kind of react as we build them. So now we've done all that, we can essentially create supervised machine learning. So we've got 4 here. We've got random forest, GLM, support vector machine, and decision tree. What you'll see is the code is exactly the same, but you're just creating it with different ingredients off your menu. So we just choose the algo random forest or the algo decision tree, and that's your picking it off the menu and just plugging it into the script to build your different models, which is great. It's dead easy.
Come on, 1 or 2 seconds here, Abby, 1 or 2 seconds each time. Now it's toy data, but it's pretty fast, right?
Exactly. So, you know, it's easy and quick to write. It's easy and quick to switch between models, and it runs quickly. Tick, 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 perfect. But now we want to compare how well each of these models have done. So we're going to use the compute lift function from the database. So it's going to do data mining.apply. It's going to apply the model to the test data, so that other 40%, and then compute the lift model for all of them. So we do that 4 times. So we've got 4 models. We do the compute lift 4 times. And then essentially the last part is that we're going to get those results from the lift and put them all into one table. And essentially that enables us to create that last graph on the right-hand side. And that's where essentially as a model performance, we're looking at how well each model's done, and you know, where the challenges are, which one we might want to discount, etc. But we can see it very quickly on the cumulative gains chart on the right-hand side. The last step then is model deployment. So essentially, once we've applied the model and we're happy with it, we can do the probability on the GLM model here, and find those that where it's yes, and we've got a high probability that it is fraud. We're ranking them. So as you can see there, as we get down to the 200s, the percentage fraud, or the, you know, how probable it is fraud, drops and drops and drops. So we've got the ones that are, you know, based on the machine learning, it looks, it smells like fraud. Okay, so we can pull those to the top and we can look at them. And again, we can look to find the 5 most suspicious customers. And these might be the first 5 that we go and say, hey, do you know what? This isn't right. Something's not quite right. And I think, where does that bring us to?
Can I interrupt just
Absolutely.
for a second? There seems to be a problem with many participants who entered Apex applications, and there is an column % fraud error. I suspect that all of these participants have not run all paragraphs.
Oh,
in,
yeah.
Unsupervised learning.
You're
so
right.
That has to be run in order to create suspicious claim table, and then you will be able to open the form here. I think the form is not created.
I think you're exactly right. Good pickup on that. Thank you. So you got to run all the notebooks in order to populate the data. This is not a, you know, we're using live ammo here, as they say, or whatever, live data. It's you got to run it to get your results over to here. Good pickup, thank you.
And
we are
just go to the notebook and run all paragraphs, and you know, just wait for a couple of seconds to run everything, and then everything will be okay.
Yeah, exactly.
Okay.
Perfect. Thank you. So where are we? We're down to here, Abby. We created our table. We put it over here for going back to Oracle Analytics Cloud. We even included, I think we skipped it last time, prediction details. Yeah.
So why did the model think that that was fraudulent? You know, giving us some of the features that it selected and
here.
said.
There they are.
So based on vehicle category, it was sport, and it's ranked that as being, and the month claimed, day of the week it's been claimed, etc. Those have contributed to that particular record being flagged as 84.42% likely to be fraud.
And what people misunderstand sometimes on this is they think this is like a decision tree rule, like there's a lot of other ones like this. No, this is the prediction detail. This is the reason why that particular record was flagged. The algorithm kind of thought these things stood out as being dissimilar to, you know, they stood, basically what we do is we perturb the input variables and see how much it changes the prediction. So for this particular value, these are the variables that have the strongest influence on that, and hence the reasons why. And again, this expensive cars, it seems to be rearing its head a few different times. So we leave the data there. One thing I want to show you real quickly, we didn't have it in there, but I just want to take you, I'll take you for a real quick spin through here. You have AutoML, which is new, and it does a lot of cool things. I'm going to do insurance fraud, if I can spell this real quickly, insurance fraud. I'll do this insurance fraud 3, just to have a new one here. I don't need to give it any comments. It's going to say, what's the data that I have in here? Now, we've loaded some data for you, and I'm going to try and find, well, the data I'm looking for is claims data of some sort, claims data. And I think the claims data is the is this one that has the target field. Is that right? That's the one with the whoops, right there, target field. So when I come over here, it loads that up, it tells me the attributes, and the target fields, there it is, fraud found. So I'm going to say fraud found, the unique identifier here, I think is going to be policy number, right? So this is all set and ready to go. I'm going to save them just because it's a good idea to save this. And this will take a little bit of time, because what it does is it does an intelligent sort of march through a number of different steps that an expert might do. I'm going to go here and say faster results. This works for classification and regression techniques currently. Does not yet work for time series, for anomaly detection, for other kind of things. But we are doing classification here, so I am going to just sort of take advantage of it. And it's going to do this automatic algorithm selection, automatic adaptive sampling, and all of this is kind of spelled out in the documentation. We don't have a whole lot of time to cover this in a great amount of detail, but it's going to do stratified sampling as appropriate. It's going to sample the data. If I have 10 billion records, it's going to keep on kind of diving a little bit deeper, a little bit deeper, a little bit deeper, a little bit deeper, until it gets sort of diminishing returns and say enough data, I can stop. And it's going to do stratified sampling. Here it's used some meta logic to say what were the techniques that we have inside the database that lend themselves to building a pretty good model with this, given this sort of cardinality of data. It is then doing a feature selection, which is some of what we showed before with the attribute importance, but it does that with 4 different techniques. It does a random forest feature selection. It does a statistical comparison, correlation, Pearson's correlation. It does a attribute importance, the minimum description length. It does a 4th one, which I always forget. And so it's done that. It's narrowed down the variables, sort of denoise in the data with variables that just sort of might be noisy, like first name. It's going to throw out first and last name probably as denoise in the data. It runs through this. It keeps on trying to iterate and do a little bit better, a little bit better. You can see how it's running. It's halfway through. And then when it's done, I am going to get my models. I'm going to get accuracies and a bunch of different information. I'm going to skip over this, go back to the PowerPoint, and just make sure we are on track. So we've done all the unsupervised learning first. Then we did the walking through the Apex application. We labeled some data using our expertise, which I think is a powerful combination using the human and the algorithms. And then we go through here. We did the attribute importance. We did our different models. We left the results inside the database, and we came back and we're showing how to use AutoML. So give this a try. You have 3 or 4 hours. You can play around with this, load up your own data, give it a go. It's really kind of powerful. So it's going to walk through that, show you different model characteristics. It's going to show you the prediction impacts. It's going to calculate a confusion matrix. You can also generate your own notebook from this. And the notebook that it's going to generate is going to be in Python code, because it's written the orchestration layer that tells you all the different sort of steps. The ML pipeline is the orchestration layer is written in Python, OML for Python, and the execution of the algorithms inside the database are with the algorithms inside the database, the OML for SQL. So the orchestration layer here is what you see in the notebook, and there you see it here. I can also, if I'm want to just simply score this model using good old-fashioned SQL here, I can just say, well, create that table like we did in the other notebook, and just create a table that just uses that really nice model that was built. Now, there is currently I guess I'll say an undocumented feature. When you go back to here, your models may be listed as, well, back here somewhere as smalls. Okay, this, make sure you capitalize, maybe make sure you upcap those things, otherwise it'll throw you an error. We're fixing that. But when I come into here, the name of the model is all upcapped, right? Make sure you do that, otherwise you'll get an error. You also have the ability to deploy the models through a REST endpoints. If you don't want to have to use the database, but you want to use database to score the model inside the database, you can use the REST endpoints. We deploy those. We're almost done here. I want to have time for Q&A with all of our experts.
Yeah. Hey, Charlie, someone's brought up an excellent point about explainability. And I was wondering if you and Abby wanted to say a little bit in terms of understanding that and consuming these models and really interpreting, also comparing with other parts of, Oracle data science and how they approach it and whatnot.
Well, there are 1,000 different ways to figure out model explainability. There's the MLX explainability that we have in down here in the prediction. It's right here. We've added this prediction impacts, which is the same, or I guess I'd say very similar. Our functionality is all running inside the database, but it's the same methodology that we use for the prediction impact. So this is telling you which variables have the strongest impact for this particular model. So what we do there is we perturb we shuffle the data. So if you have dog lover, cat lover, or whatever, and we get a model and we shuffle those values, we see how much does the model change. So they use a similar technique for that. That's what we're doing here. We also have the prediction details that I showed you. Yeah.
I mean, I would say for those of you that are used to doing traditional regressions and looking at a coefficient of determination or something like that, I mean, this is doing the same kind of thing. And what we're looking for is what are the keys, because often in those kinds of, when we're comparing our variables, we find this kind of logarithmic distribution where we have some really important ones and a bunch that are as contributory. So that I would worry more about or pay attention to, what it's saying as opposed to what's the math behind it and all the ratios and whatnot.
It's got to make sense, and then each algorithm is going to have its own like coefficients for a decision tree or a split criteria for a decision tree or coefficients for a GLM and so on. So that gets to be sort of a arbitrarily complicated discussion if you wanted to. What I'm going to suggest is that I think the best way to do that also is to come in here and say, oh wait, there's more. I've got all these results. I've got this very nice visualization interactive product now called Oracle Analytics Cloud that I can go in here and see all the ones that are is it likely to be fraudulent? Yes. And I can see, well, driver rating, and I can kind of interrogate the results, the insights, and make some more sense out of this. So that's another way I would suggest to kind of get a little bit of a feel or comfort level that that it's not a black box. I mean, we're going to give you the coefficients, we're going to give you the prediction details, we're going to give you the prediction impact. There's a number of different ways we sort of triangulate into that. But I think the OAC thing at the very end is also very good. And I think in your live labs, it will tell you at the very end, as you get down to here, to look at it both in Apex, which is one of the things we do. That's the last graph. If you're doing the always free tier, I clicked on the instructions for the green button. If you go to the always free tier, it's going to take you a little bit further, and it's going to tell you how to get into Oracle Analytics Cloud, because you have to have your own instance for Oracle Analytics Cloud. Now, I want to just tease upon this because I want to make plenty of time for our experts to answer any more questions. And I just want to sort of show this real quickly. You have to have your own instance. It gives you the instructions how to set that up. I have my own instance here, so I'm just going to go directly into this. And now this is the Oracle Analytics Cloud with these filters for driver rating. Well, I can put a filter down here. I can put witnesses present, yes, no. I can say, what's the prediction, yes, no. What's the vehicle price? And I can say, oh, just these guys here, what's going on? And I can kind of interactively kind of play around with this. I think it's just wonderful to kind of get a feel for what Tim was talking about. Also, the other thing that I like over here is we've served up all these prediction probabilities. Like, where is it? Prediction probability right here. And I could filter this just to say prediction probability, the ones that are, I don't know, really likely to be fraudulent or something like that, and update the data here and just kind of drill through this. And I can do things like, I can use data brushing on. I can say just these guys over here, the sport vehicles, and I'm able to sort of drill through all this and really use the power of the predictions and the insights. With that, I'm going to wish you guys well to go through all that. I'm going to go back to the PowerPoint and see if there's any last thing we missed here, and then I'll leave it open for Q&A. So there are many, many links that I think we can put out there. You can go to oracle.com/Oracle Machine Learning. You can go to this blog page where I put a lot of other links to things. Save the date for the next TechCast. Thank you to all of our people. Now, I just want to set this up before we go back to Q&A. There's another session coming up right after this. Marcos Arancibia is going to lead us through, with Mark Hornick, going to lead us through Oracle Machine Learning for Python. In order to do this best, it makes sense if you are done with this live lab, shut it down. It'll take 2 or 3 minutes to shut it down. And then you're going to want to launch the new one, which is in the instructions. And Carrie, you may want to post that in there so everyone has access to that. But you want to stay tuned for this. This will start in what, 10 minutes? I want to go back to here and I guess take us back to the top. Any questions or any comments from all of our esteemed presenters? Abby and I have done a lot of the talking here. Let me put it up to the rest of our people who are, by the way, available. Giga, Abby, and Tim have volunteered to do these consultations with you. If you say, hey, that works for me, but I do trucking over here. What's this got to do with trucking? Or I do restaurant business, or I do, you know, I don't know. Take advantage of that. We arranged this. It was through the help of these volunteers. Take advantage of that. But why don't we just start that out right now? Are there any questions or use cases of any kind, or any comments from any of our most excellent instructors here?
Charlie, one thing that I would like to highlight is if, for example, people want to go to also do the next amazing lab that Mark and Marcos has, where they can just, you know, drop the environment that we have now, but they can go again and go and launch another time this hands-on lab. Also create their own cloud tier for free, always free, and they will have the instructions in a different way, and they can do it by their own pace. And also something that's about the samples that you have in the autonomous data warehouse, in the notebook samples that you have, examples that you have, that you can, you know, in the examples you can only see the content. It's read-only, you cannot modify it. And how you can, you know, just export and import the JSON file in order to create your own notebook with this content and just play with it.
Adel, is that what you do with customers? You use the templates?
No, but for people that want that, just training them, I think it's the best way for people to be familiar with machine learning, and I think it's a good way to do it.
Yeah,
you know, just playing around.
Giga, any comments, advice, anything here while we wait for questions to come in? Any comments from you?
Not particularly. I maybe just to wrap up. I ran the whole workshop again, and yeah, all the steps have to be completed before the Apex is used. So that's one thing that I was trying to confirm. But otherwise, I think you know, the combination of Oracle Analytics and machine learning, I think this is very powerful combination. You can register the models that we are creating. For example, the classification models, we've done 4 of them, and all can be registered with OBI. And when you get the new data, you can just simply run against them. So I think this is a very powerful feature, and I think many of users will be using them.
Now, some of you guys are in Thursday's session with OAC, where you're going to talk about that a little bit more, right? Are any of you instructors in that? Adel, you're in that one on Thursday?
Yes, we're going to talk on Thursday on the data visualization part, the data preparation, and at the end of the machine learning a little bit. But yes, you can import the models that you created here. And this is something that we already talked with Charlie many times. Use the right tool for the right job. So machine learning and autonomous data warehouse is the most important, you know, powerful thing to use machine learning. But Oracle in its cloud is amazing for data visualization. So the idea of have this tight integration between them is the right way to work. So you imported the machine learning models that you created, and you visualize and analyze the information with many data visualization options that you have in OAC.
Yeah, I think there are a lot of situations where we're dealing with highly dimensional data, and what's really nice about the Oracle Analytics product is that all your visualizations are automatically linked. And so that by creating a panel of visualizations that are rich, you can get kind of a multi-dimensional representation. Otherwise, it's really hard to see what pops out. So we know that we don't see in 12 dimensions, right? but we can set up a panel of several, three-dimensional visualizations or 3 dimensions, and kind of, let our eyes wander over them, and through the interaction kind of see some of the relationships. It's pretty interesting stuff.
Abby, any more comments from you?
Nope. Been a good session. Hopefully everyone's had an opportunity to get their hands onto Oracle machine learning and had a bit of fun finding the fraud and getting the intelligence out of Charlie's head.
I wish we got some sort of a bounty for capturing all these crooks out there, huh? That'd be a lot of fun.
I know. It would have been good to have locked someone up.
That'll be the next hands-on lab. We'll have a little bit more excitement. All right, guys, I'd like to thank all my panel, Abby, Tim, Adol, Giga, Carrie, Dayton behind the scenes for making this thing all happen. Really, really appreciate it. You've got 4 more minutes, I think, until the next hands-on lab comes on with Marcos and Mark Hornick, and I am going to somehow put it on that last page so you can see that. Abby, not Abby, Carrie, you might as well start putting the links for the next one. Remember, you want to shut down the one you have, because you're going to want to go into the next one and start out clean, hopefully. So with that, I'm going to Marcos and Mark, are you out there somewhere?
Yes, we are. Hello, everyone.
Yes, we are here.
All right, guys. I think you guys officially start in like 3 more minutes. So yeah, I don't know if you want to just start right into it, a hot start, or give them a couple of minutes, but we're going to sign off and say thank you, everyone, for attending. I'm going to stay on this one as well, at least for part of it, and I hope you do too. So thank you, everyone. Thank you for all my great speakers, and good luck, Marcos and Mark.
Okay, thanks, Charlie.
Thank
and
you.
So we'll give folks a chance to get a break for a few minutes, and then we'll come back and start the session.
And during that break, Charlie, is it okay if we can go ahead and announce the winner of our $25 gift card for the ANDOUC merchandise that we were giving away for our participants?
Thank you very much. Yes, it would be great if we could do that. Who is our lucky winner today?
So our lucky winner today, who will receive a $25 gift card to redeem and utilize for any of our merchandise on our ANDOUC website, is Karen Ember, if I'm saying that right. It's IMBER. So Karen, we have your email address. I will shoot you an email with the gift card information and instructions on how you can redeem it and get yourself some free ANDOUC merchandise.
Excellent. Merch. That is incredible.
Merch. Yes.
All right. I'm going to go off camera and mute here, and good luck, guys.
Thanks, Charlie.
Thank you.
Hi, everyone. Welcome. Welcome to this session this afternoon. I'm Marcos Aracibia. Mark, I think, is also joining us.
Yes.
Mark.
Hello, Marcus. Hello, everyone. Welcome to our session.
And then we also have Sherry LaMonica as well. She's going to be on looking all the Q&A with you guys, any questions you guys might have. So the idea for this afternoon then is actually taking you through a hands-on lab on Oracle Machine Learning for Python. This is basically what we're going to be looking at in terms of steps, right, and the agenda here. So it is a test drive, right, for the OML for Pi. It's available already on all Oracle autonomous databases, the data warehousing, transaction processing, even the JSON, right, database is also available there. The idea here is to explore different aspects, right, of the Oracle Machine Learning notebooks, especially using the Python API. And we're going to be working with data. You're going to learn how to interactively work with data, process that information, and build machine learning models, and even use the AutoML, right? All of that from the OML for Pi. We do have some try it yourself exercises as well. So we're going to let you play with that component. We want to set the expectations, though, before we begin, right? So the objective here is really to be familiar with the OML for Pi, become self-sufficient with the environment. If you want to come back to the LiveLabs and use it again at your own pace later on, it's going to be available, right, for you. So you can always come back and try it again, or take a look at that, or get more details. Maybe you don't remember something you saw there. You can actually always go back. The lab is going to focus only on OML for Pi now. There is some REST APIs that we can give you guys probably more information later on different sessions. AutoML UI as well is available, and I think Charlie talked and alluded to that as well. So, but this current environment is going to let you play with OML for Pi and all of these command line using Python, right, and in the notebooks. So if you want to learn more about machine learning in general, right, I highly suggest you take a look at our sessions that we did in Ask Tom. We have a lot of sessions there that actually explain this 101, right? What is a classification? What is a regression? What is a cluster model? And things along those lines. So for the agenda, we're going to start by making sure you have access to your LiveLabs. And this is important because it will take a little time to get it up and running. Then we're going to go through an introduction to OML for Pi. I'm going to talk about each lab and an overview, right, of the features. We're going to work through them, and then we're going to end up with a Q&A. And the Q&A is going to be very interactive. So you guys, at any time you guys have questions, please just ask, okay? We ask you guys to ask questions on the Q&A. And if you need any lab help specifically, then you can chat in the chat to panelists. We're going to have Mark and Sherry as well looking over those. And we're going to distribute links to you guys through the chat, okay? So first things first, let's get you guys accessing the LiveLabs instance and ready. So for that, we're going to send out a poll if we can. Okay. So here's a poll basically asking whether you guys participated on the previous machine learning hands-on lab, right? You might have done it as, you were just watching, or you might have started your LiveLab environment, or you didn't use, right? So we want to know that, because that's going to be important for us to understand. So we see that we got 35% of the respondents here say they actually used our LiveLabs, right, environment. So that's good. And then the next question is going to be related to your backgrounds a little bit on the technology, whether you're familiar with these kind of technologies that we're going to take a look at. Oh, sorry, that's not the right poll right now. Apologies. there was a poll about the technologies. Yeah, there you go. Thank you. Thank you very much. So just wanted to check with you guys, which kind of, what kind of technologies are you guys familiar with? That will give us an idea. All right. Great. So I see a lot of SQL usage, some R, a little bit more Python, Zeppelin notebooks, Jupyter, more Jupyter than Zeppelin, and a good chunk of REST APIs. That's excellent. All right. Thank you very much, guys. So to begin then, what we're going to do is, because for the people that joined the previous session, you're going to have to go back to your My Reservations, and you're going to have to click on the trash can to cancel that reservation. Okay. So if you look at my screen here, basically you have that session and you have the last session that is running. The status is going to be available, right? Because the original timeline for that workshop is going to last, I think, for 4 hours. That's the standard that we have there. So if you can go there and then click on the trash can and confirm that you delete it, we would appreciate it so that you can use ours. Otherwise, you're going to get an error at the bottom of the screen. You see, if I try to launch a new one while another one is already running, you're going to get an error on information that you can't have parallel sessions running. Okay. Okay. So having done that, then I'm going to ask Sherry to share with you guys in the chat the following link, right? The link regarding the our LiveLabs. So if you can take a look at that LiveLabs right now that Sherry just shared, right? If you click on that, you're going to see the screen, right? So I'm going to go there with you guys. So I'm going to go there with you guys in this exact screen. So I can say, reserve workshop, right, on the LiveLabs, right? That's going to be the idea, right? And then we're going to be able to do that. I am having some trouble here with that link right now, and I guess that might be some reservation issues. So hopefully, if you guys are able to oh, yeah, there we go. This link over here. So the idea is clicking on that reservation, right? And then in this screen, what I want you guys to do is leave that start workshop now. So as long as you don't have the other one running, right? And then you're going to click on consent to receive reservation emails, and then submit reservation. Okay. Now, all of that requires you to have an Oracle account. Okay. So once you want to do that, then it's going to request we're going to see that this thing is going to require you to use your Oracle account. If you don't have an Oracle account yet, right, then the idea is that it's going to ask you to sign in, and if you don't have the Oracle account, please create one. So many of you that already used the previous one probably have an Oracle account. I imagine most of you have an Oracle account. It's a free account. You can create it. You just go in there, create your Oracle account, and then fill in that information. You will need to give, I think, a phone number at some point. But then you click create an account, and then just check your email, right? In your email, you're going to then get that information about that account, and then we're going to be able to show you all the components that you can do, and then execute on the go back to log into your workshop. Okay, so again, making sure that you guys have already were able to get here as I did before. Start the workshop now, and then check the button to submit reservation. And then I expect you guys would receive an email for that, right? Now, if you click on View Your Reservation, you're going to see a screen called My Reservations, right? And then we're going to see that process. And then the idea is that at some point, you're going to see an estimated remaining setup time for your reservation. Okay, so we expect that's going to go through and then process. Now, I see some people are having perhaps some issues with the reservation. So Sherry, can you please share with people the instructions again on the chat? So one thing that I wanted to make sure, we created all of these slides that I'm showing you right now. We created all of them in a PDF that is easy for you guys to follow. So if you fall behind what I'm speaking, you guys can revert and check that PDF, right? So that's the link that Sherry just shared with you guys in the chat. So that is very useful, because then you guys can come back and you know, follow the instructions step by step. Okay. So if everything went okay, you would have the reservation and a timer. I see there are people perhaps had some trouble with reservations. Just refresh that page and check again. They might have been receiving a lot of reservations right now in that system, so they might need some time. And then you just, if you guys can refresh that, that might be a possibility. Okay. So so I'll then, if you guys have technical difficulties, please talk to us on the chat. I'm going to run a quick video, and then we're going to check back. Just one quick second.
So you have enterprise data managed by Oracle Autonomous Database, and you have data scientists who use Python. Data scientists need data. The database has data. What if we could bring these two great technologies together? What if data scientists could use familiar pandas data frame functions to explore, prepare, and analyze database tables and views as though they were pandas data frames transparently? What if data scientists could build machine learning models at scale directly in the database using those same familiar pandas data frame proxy objects and a native Python API to in-database algorithms, and leverage automatic machine learning, AutoML, as a productivity tool? What if data scientists could couple this with additional Python packages like scikit-learn and matplotlib to develop and deploy solutions with user-defined functions stored in the database, and then using REST endpoints deployed easily using database spawned and managed Python engines where functions and data are automatically loaded, even with parallel options? Well, with Oracle Machine Learning for Python and Oracle Autonomous Database, data scientists can do just that. So what are you waiting for? Learn more at oracle.com/machine-learning and take OML for Pi for a free test drive in Oracle Autonomous Database.
All right. So basically then let's go through an introduction. And again, if you guys have any problems provisioning or keep having any trouble, please message us through the chat window, okay? And then we're going to make sure that you guys can see all of that information, right? So I guess, you know, if you guys have not joined Charlie's session before, right, you might not have seen this. So real quick, the idea with Oracle Machine Learning is that we have an extensive components that work with different interfaces, right, and different UIs, but the objective is the same. It's working within the components that Oracle Machine Learning provides and the algorithms that we provide, right, and all the facilities that the Oracle database provides. So on the left-hand side, we have basically the three popular data science languages, right? SQL, R, and Python, and those are the languages we use with Oracle Machine Learning. On the right-hand side, we have the Oracle Machine Learning notebooks, which is what you're going to be using today to work with the Python, right, in OML notebooks. So that works on inside the Oracle Autonomous Database, and it's based on Apache Zeppelin. And then we have the Oracle Data Miner as well. That's the very powerful UI that runs inside the Oracle SQL Developer. And that is running on a desktop and against the Oracle database on premises and Oracle database cloud services as well, that are not the autonomous one, right? The other ones. And then finally, we have Oracle Machine Learning for Spark that runs inside the big data service and execute algorithms there in the cluster, right, in Spark. At the bottom now, we have the two newest additions to the family, the Oracle Machine Learning AutoML UI, which helps you with the AutoML aspects, but in a very user-friendly way, right? It's a complete click and drag and drop and just click buttons interface, so you don't have to code, and you can use all the advantages of AutoML that we provide. And finally, the OML services, where actually you provide and you actually deploy the models to, so it can handle not only a deployment of the Oracle Machine Learning in database models, but also ONNX formatted models, right? So, and as a quick view, we're going to actually be using this interface. This is the Oracle Machine Learning notebooks. So basically, the idea is that this environment is very collaborative. You can create groups, you can create projects, you can give authorization to people at different levels. You have a good support. We have Python and SQL and PL SQL now. We are working on the R as well, that we're going to bring hopefully this year to the interface. And then the idea with this is you actually get these notebooks that speak several languages, and they can interoperate and work together, right, to actually get to your objective. So you can get plots from matplotlib in Python, right, and you can get the SQL, right, the powerful SQL and PL SQL from Oracle database. So these are all included in the Oracle Machine Learning under Autonomous Database. And in general, the OML for Pi, which we're going to be seeing more details today, that is actually what we built for taking advantage of the Oracle database and treating that as a big, HPC, right, cluster, if you will. That actually can execute things on the server, which might be too big for your laptop, for example. And also, you can take advantage of transparency. So you can use all of these transparent functions and the parallelism that the database has through a very simple Python command that you're used to with, pandas interface, right? At the end of the day, we can also send these commands and this open source Python code. We can send it and ship it to the database so the database can reuse it or can execute it and even can run it in parallel, right? We're going to see some examples today. And then at the end of the last point in that slide here is that we bring the AutoML UI functionality, right? AutoML was developed by our Oracle Labs teams, and this is very powerful. It's specifically tailored to the Oracle Machine Learning in database algorithms. So instead of you having to look for the best model, this is going to actually do an automatic checking on all the models we have available and identify that what are the best hyperparameters that make that model the best to target to your problem. So it is a very interesting process. And we also have the machine learning explainability, or MLX, component as well running there. And we're going to see details about those. So about the labs overview then. The idea here is we're going to go and lab 1. I'm actually going to just drive and show you guys lab 1 because it's probably not available yet for you guys to get it, but it's just very basic. It's just getting situated with OML notebooks, right? And then the second lab, we're going to check select and manipulate data using the transparency layer. We're going to use a database in database algorithms and models. Lab 4 is data stores. So how to store Python objects directly in the database and use them, right, on your programs. And then we're going to run some user-defined functions with embedded Python execution, number 5. And final lab 6, we're going to go through AutoML. Okay. So Getting started with OML for Pi. Basically, once you get your environments ready, you're going to be able to sign in into your Oracle Machine Learning notebooks. And I'm going to show you guys the details, and they are on the instructions that we just shared. And then you're going to be able to click on notebooks and then click the notebook lab 1, where we're actually going to have to import the lab 1 notebooks, right? So I'm going to show you guys how to do it. So what this guy has basically is it's showing you the different components, right? For the lab 1 getting started, basically on the top, you see you have a few buttons, right? You have run all, which means run the entire notebook from beginning to end. Show or hide code, show or hide output, right, of every of these pieces of the notebook. Clear output, clear the notebook, and you can export the notebook. So after you made some tweaks or you finished that, you can actually click a button, export it to your laptop, right? And on the right-hand side, you have a few important things. The connected users list of shortcuts, but actually the interpreter bindings is probably very critical here. The interpreter bindings is going to allow you to select the mode that you're going to run. So, you know, medium, high, or low. And then you're going to have to make sure that you have an interpreter binding. And that's typical, right? You're going to have to make sure that it's there. Okay. And then for each paragraph, you have a little set of buttons there as well, right? So you can make sure that the status is finished, right? If it's running, it's going to show you that it's running. If there was any error on your code, it's going to show error, right? And then you can run each paragraph, and then you can show editor and hide at the editor, and then have more features where you move around. You can move the paragraphs in order and things along those lines. So these additional features is important because you might want to change the width of each of the paragraphs, put them side by side. You might want to show a title, so you add a little title to that paragraph itself. And then are a few other things that you might find useful as well, and including disable run at some point, just because you might have saying, I'm testing some code and I don't want it to run, so you can disable run. So when you run the entire notebook, that paragraph is not executed, right? And that might happen if you're testing things out. So so before we move on to number 2, let me go then to our number 1, just to show you around, right? So this is the Machine Learning for Python Lab 1. As you saw, you have all that drawing that I just showed you. But for example, in a few things here, we're talking about interpreter bindings, right? So when you go up here and interpreter bindings, and you click on the little gear, you need to make sure that you have at least one of these guys selected, right? So in this case, I'm running the low and the markup language, so I can write these nice things, right? Nicely formatted text. You can move around things, but it's only going to take advantage of the first one. So if you have, even if I had selected, right? If you click on them, they become blue, so that means they're selected. But if I have this, that means that the interpreter is going to look at the first interpreter that can understand SQL, right, and Python, and then it's going to use that guy. So even if I highlighted the medium and high here, it's only going to use the low because that's the first one in the list. Okay, and then make sure that any changes you make, you want to click on save. Okay. All right, so I'll discard any changes, and then just to show you around, basically. When you have the interpreter for Python, right? When you type %Python, it's running Python already, right? So this is the Python component. So we're going to have at all times to import OML. That's the Oracle Machine Learning libraries for OML for Pi. So that's going to be your first step all the time. You can check whether Python is connected. By default, in Oracle Machine Learning, in autonomous database, it's always connected, right? You do %Python, you're going to be connected. And then you can do just like you do with Python, you can do help. So I do help on OML create, and this is the answer, right? So I'm going to get the help on that specific command, right? And then help on OML, it just gives you a description of what the Oracle Machine Learning is, and tells you all the classes and all the different things that we have. Okay, so that's basically it for that process, right? For the lab one. So that's why I did not want you guys wasting your time with it if we don't have it ready yet, right? The environment. So let's take a look at lab 2, and then by the end of lab 2, probably most of you are going to have the environment ready, so we can take a look. Okay. So the transparency layer then, basically that's running an in-database, taking advantage of the in-database components that run in parallel and very fast on the Oracle database by using simple commands that in Python you would use as pandas, right? Against a standard pandas data frame. So for example, you can do OML create. You can say data table equals X. That data, as long as that data is a pandas data frame, it's actually going to be pushed to the database and it's going to be created there. If I then do an OML sync, right, of a table called Boston, that data, the capital data now is telling the database, hey, I would like to create a proxy object locally that is pointing to that table with that name. And with that information, we can do all of these, normal commands that you use in Python, right? So I can check the shape of that data set. So how many rows and how many columns. I can have, head, show me the first stop records. I can have a describe, show me a quick description of that database, a standard deviation, skewness. I can do a split. I can do, then a shape on the training, shape on the test, right? So these are all compatible with the commands that you normally would use with the pandas data frames. The only difference is you might be actually doing those things on tables that are millions of records, right? Because the Oracle database is taking over that process behind the scenes. So we have a lot of the different data transfer related functions. With OML create, you're actually pushing data and creating a physical table in the database with the data you're passing. You have OML push, which actually you push some table, some data that is locally to a temporary place, right? And then you get a proxy temporary object that when your session is done, that data is gone, right? You're not going to be able to recover that data. Then you have OML sync, where you actually say, okay, I would like to connect to data that is in the database. OML sync will actually take a name of the table, a name of the view, or even a query. You can actually just write a SQL query of what is the result that you want to point to as a proxy object, and you can, right? So you can type any Oracle SQL query at that point. Then you have a drop, so that you drop a table or view, and then the directory, right? So dir, so you can check the name of the OML objects that are available to you, and then OML cursor as well. So you can get a cursor for that Oracle database connection directly, okay? So for example, if you want to do an aggregation, right, in the Oracle database, then this is what you're going to do. You're going to do ontime as OML sync. So now the ontime underscore as, all in caps, is actually a local proxy object from Python. I will do then a cross tab on destination, and then I'm going to say what is the type of that, and then what is the head, right? Show me the first few records. So what's going to happen here is you're going to actually get that process executed. OML for Py is going to ship that information to the database, and the database is the one that's going to be loading that information. So basically, the translation to what I'm trying to do is a select dest count star from that, right? And group by. So that's what I'm doing, but I'm not typing all of that, right? I'm just typing my Python pandas. So the database is doing all of that count, and the result is like this, right? So the type of the response or the result that you created is an OML core frame, right? Data frame, and then you see the quick response there. Okay. So just like that, we have all of these other functions here available, right? For OML for Py. So all of these functions are available in the environment for you to use transparently. And then, so let's take a look at the lab 2 then. So the idea will be to import the libraries and create the proxy objects, select some table columns, select rows, use Panda data frames, use split functions, crosstab, and do a box plot and histogram. Okay, and finally create a persistent database table. So right now, I would like to run a quick poll to check if you have received your emails, right? That your live lab environment is ready. So for those of you that that ask for that, Carrie. Sorry, Carrie, could we show the, oh yeah, there we go. Perfect, thank you. All right, so we want to know whether you guys have received that email that says your environment is ready.
We'll give it 4 more seconds.
Thank you. Okay. All right, so we got, I guess, 3 people that have not yet received their emails. So if you guys are waiting for the session or had any trouble behind the scenes with getting it going, please let us know in the chat, okay? And then we are gonna be able to talk to you, okay? Yeah, we see there are a few people having problems with the reservation or something like that. So if you guys can go back and refresh that page or close the pages and open up the pages again, that'll be a great idea. Okay. All right, so I'll have Sherry and Mark take a look at you guys and work with you on the chat questions. I will just expecting that if you guys receive that email, it's going to look something like this, right? So you can either make sure that the environment says that it's ready, right, on your email, and then you can click on that link. If you don't want to click on that link, I mean, you can click on the other link with the reservations. And I think, Sherry, if you can share that reservations link again with everyone in the attendees, just so that they can go back to there. I imagine you guys have that page open already, but if it's it should be there. So if you guys can click on that link, then you guys are going to be able to go here to your My Reservations, and then because it's ready, it's going to say now you have available, right? And it's going to show you have a launch workshop. Okay, so with the launch workshop, then you can click on the launch workshop, and then you're going to fall and you see this image here, right on the top. So on that one, I want you guys to click on the launch console. Okay. So the first time you come here, right, it's going to say the launch the console. In the single sign-on screen, you're going to have to enter. It's going to give you already a user, right? You're going to be it's going to be pre-filled for you the name of your user for the LiveLabs, but it's going to ask you for a password, right? So going back to the screen here, you have an initial password here, right? So this username is the one that they pre-filled, and the initial password is the one that I need you guys to copy. So you can click on that copy password because that password is usually very cryptic. You can click on the copy password, and then you're going to be able to paste that password over here. When you do that, you can sign in. Now it tells you to change the password. So as long as you guys can remember the password, you can change it to something you might remember. I normally take the lazy way and just paste the same password over 3 times so that I just keep it simple so that I don't have to remember new passwords and I can go back to that panel and get it when I need it. So you can just paste that same password 3 times here. It's fine, whatever you guys want to do. And then you should get to the Oracle Cloud infrastructure, right? So now we're going to click on the hamburger menu, and then we're going to go to Autonomous Database, right? That's the autonomous database under the featured section here, okay? Now, if you guys are logged into other OCI accounts and you have them open, there are people that have some trouble sometimes. So you might want to watch for that, right? If you have any trouble logging in, or you're logging in, but that's, you know, the other account that you have, that might happen. So you might have to log out of the other OCI tabs that you might have open, okay? So once you're here, then what you're going to need to do is in the autonomous database list here, you're going to have to click on compartment. And under the compartment, you're going to have to search. So you expand the LiveLabs and search for the compartment that has your name on it, okay? So if you are, in this case, I was LL3900. So I click on LL3900, and only then I can see my autonomous database displayed here. Okay. So if you guys are here, then in the autonomous, make sure you click on the right compartment. You get into the autonomous database list. You see yours. Now you can click on that autonomous database that we have reserved for you. Okay. All right. So now we're in the autonomous database. We're going to click on the service console. And then we're going to go here. When it gets to service console, you're going to click on development. And then down there in development, you're going to be able to click on Oracle Machine Learning Notebooks. All right. So again, service console, development, Oracle Machine Learning Notebooks. So then at this point, we get into the Oracle Machine Learning Notebooks. Now, when we're logging in this case, the user is always going to be OML user. That's a default user. And the password is exactly as I'm putting it here. So I think, Sherry, maybe you had a text about the user and password, or maybe not, but you might, if you can share with the people in the chat, just so that they're make sure that they don't inadvertently put something wrong there. So user is always OML user, all caps. Password is AA all caps, then BBCC 123456. Okay. So once you're in, then at this point, we're going to click on Oracle Machine Learning Notebooks. Okay. So if you're now coming to the Oracle Machine Learning Notebooks, we're going to go back to the workshop, and we're going to click. We can collapse the section that is below that, and we can click a button that says open the workshop instructions in a new tab. Okay. So that is going to bring you to this page over here. So now you have OML notebooks on one tab, and you have this guy, which is instructions on the step-by-step of all of our current lab for today. Okay. Now, there is a couple of ways that we can do the OML for Pi labs. One way is for you guys to go by yourselves and click every button here. Okay. The other one is for us to actually download the notebooks instead of having to copy and paste every paragraph from here. The good thing with it being this way is that it has an explanation, right, on the step-by-step explanation of what's happening, so that it's easier for you to look at afterwards. But if you focus on that, there are specific instructions here that they're calling optional, which is download and view the notebook file itself. So what we have done is we've actually zipped all the labs for you. So Sherry's already shared with you guys the link in the chat. Please click on that link. You're going to download all of these notebooks at once. Okay. These are the exact same notebooks that you would have downloaded from the instructions, but we just have them zipped up for you. What we're going to do with those is we're going to take those notebooks now from the zip file, unzip it, right, uncompress them, and then we're gonna basically go back to our Oracle Machine Learning Notebooks tab, and then we're gonna click import, right? If you go right now there, you should see nothing there, right? There should be no data to display. There's no notebooks there. What I want you guys to do is click on import, then point to your machine wherever you put your notebook files, right? So your 6 files there, JSON files, you just click open, and you should be able to see them like this, right? This is the state that we expect you guys to be in. Okay. So so right now, then what's going to happen is we're going to go and then on the notebooks, I got a few more than you guys, but on the lab 2, then the idea is we're going to, as I mentioned before, we're going to be looking at all of the different data components that we have. Let me just refresh. I might have got myself yeah, out of the logged out here. Okay. All right. So anyway, what I want you guys to do is to make sure that you guys can pick up that the notebook. I'll switch to one of my other instances so I don't mess with you guys and try to get you guys your reservations and then not abuse that. So in any case, the idea is that I'm gonna give you guys some time now to go through the notebook. You're gonna go into lab 2 notebook, okay? And then you're gonna go and look at the notebook and go step by step through it, okay? So we're gonna start at the beginning, and remember, every time you click on a notebook, on the paragraph, if you wanna run it, you gotta run the previous paragraphs, okay? Especially the import OML. If you skip that and only try to run one of the lines in the middle of a notebook, it's not going to work. It's going to give you an error because they are dependent on data that they created before. Okay, so let me give you guys then 10 minutes, and then please write and ask any questions in the chat and Q&A, and I'll be waiting for your questions. Okay, one of the questions was, I think a person is on the autonomous lab. Oh, okay. Yeah, I mean, quite frankly, if some of you are still running the previous lab, I mean, you know, if you download these notebooks, you can actually always import them into the previous lab as well. I mean, that's not a big problem. Okay, I see one comment in the Q&A that for some people, the looks like the list of compartments was empty, but then they logged out and logged back in, and then it worked. So if that's happening to you, then logging back in might help as well. Thank you, John. Okay, guys, 3 more minutes, and we're going to move on, okay? If you have any questions, again, any problems, technical problems, please send it on the chat and Q&A as well for general questions. All right. Okay, guys, so we're going to move forward because we're getting short on time, and I want to make sure that you guys can take advantage of all of the components, okay? So for lab 3, then, we're going to be using database, in-database algorithms, right? We have a list of algorithms. You've probably seen from the previous session, the full list of algorithms that Oracle Machine Learning has. These are the ones that we are exposing for now, release 1.0 of OML for Pi. The intention is to get in parity and then expose all of the algorithms possible, right, over here. Then the idea, again, is to run the algorithms, right? We're going to say import OML, right, as always. Inside OML, we have the algorithm specifically. So for example, if we do something like an on-time and OML sync, so now I get the proxy table for that, and I define the model object. So there are settings that all the objects in model, right, they will take. So the basic settings, in this case, for my support vector machine, I'm defining an outlier rate of 0.01. But you know, you don't need that. You can use the defaults, but normally you would try to do some of that. And then the second step is to run this support vector machine. So you can actually execute that anomaly detection, for example. And then you can say, what's the kernel function you want to use and the settings, right, that you want to execute. So when you define that SVM underscore mod object, that now becomes your model. So then you can fit that model using the data, right? So that the second to last step is fit the dot fit. So you're going to fit that model using the input data set. So you don't have a Y because this is an anomaly detection algorithm that you want to run. And then you can just check the model, right, the output. So as partitioned models go, this also supports all of that. So it supports automatically the partitioning, right, of models. So you can have a model with a lot of different partitions, partitioned by region, right, by sector, by age group, whatever you want to do. You can actually do that, and then it's going to automatically build one model per partition in behind the scenes, and then it's going to be able to actually score models with that as well automatically later on. So let's take a look at lab 3 then. We're going to import libraries, run a regression, and then run a k-means algorithm and do partition models, okay? So this time, instead of giving you guys a timer, I'm going to actually go there with you. So if you guys are already there, please make sure that you go into your environment, right? And then what I'm going to be doing here is I'm going to be myself checking into the workshop as well, just to make sure that I'm there with you guys, right? So we're making sure that we're doing the same things, okay? Okay. So again, you should be able to see your lab 3 available there in your notebooks, right? That was number 5232. Okay. All right, guys. So I expect you guys are already taking a look at the lab 3. I'm going to go quickly through it. as well as soon as I can get it going. Let me see. I might have other things running here at the same time. Okay. I'll leave it there. So I hope you guys, if you guys have any trouble, let me know. Tell us in the chat. If you're having any troubles opening it, your notebooks. Okay. And then what I'm going to do now is I'm going to just try to open up these labs in one of my other instances just to make sure that I can show you guys around. Okay. Okay, so basically, if you guys have been able to open it up and then start working with it, you're going to see we have, again, the same section of importing all the libraries that we need, right? And then working with GLM. As we mentioned before, you do give some, you can give a general query, right? So my query can be all of these, select all of that. My second query that I'm running here is all these specific select. And then I can do a merge, right? Directly, transparently, like we've seen it in the session number 2, lab number 2, right? So now I have that customer customer_df, right? Custom_df. So I can do a head and check the first set of records and things along those lines. Remember, I can just split, so I can tell it the ratio of split 60/40 for training and test. And then you're going to be basically allowing the settings for the GLM model here to be things like feature generation or a feature selection, right? I'm enabling. And when I run the fit on that, if I give it a model name, it's important because then that model name goes into the in-database model itself, right? So instead of getting just a random number that is by default what you're going to get, you actually get a nice model name that you can reuse in SQL very easily, right? And then this is the output for that model. So you get all the weights and the information about the quality of the model, all the attributes, coefficients, and things like that. And then you get fit details. And then we have pieces, right? How to get the pieces out of that model. You get plots. So for plots, we are going to be using the matplotlib, right? So that's where you call it PLT here. And then you get that information. So that's your typical prediction, right? Versus the original data, right? The actual versus predict. And then you get here the residuals, right? Which you can see there's some strange noise in the residuals. So they are definitely not random, right? Not white noise as we would like. And then there's step 3 for clustering, right? K-means. So K-means clustering. same kind of the algorithm for, but this time is for clustering, and then you're going to be able to check the clusters themselves, right? So at this point, doing something like this, okay? So, and then finally, the partition models. I expect you guys, again, to have looked into all of these things. And then for the partition models, in this case, we can use SQL to retrieve the prediction details, right? Prediction details come in XML format, right? And they are stored in there. So just to illustrate them a little better, visually speaking, this is an interesting way to look at them, right? Using an XML table function to parse the XML that's coming back, and then that easily shows you the most important attributes, right, to determine this customer 1 is this and customer 2 is that, right? So then, I think the last step was using the model explainability as well. So so you can use MLX to get the quality of the algorithm, the feature importance, right, output. So with that said, let's go back to the slides, and then we're going to switch to our next section. So lab 4. So this one, it's going to require you guys to do some more work. But in this one, basically, the idea is you can store and load components from Python directly on the as objects that persist in the database. And then you can actually recall those objects and run them later on, right? And the good thing is run them not only from Python, you at that point can bring them up over into an Oracle REST API, for example. Right? So these are the functions, right? You have save, there, describe, load, delete, grant, and revoke on the data stores themselves. And then we're going to take a look at lab 4. So what I'm going to do is I had instructions here on how to create a new user, just because there is a step here that is step number 8, that you can manage the data store privileges, and you can give another user the privilege to read your data store, right? So that you can share that with the person. So instead, I'm not going to go through this because of the time, but the instructions are there in the PDF, so you can see how to do those things. You can go back and create in the machine learning administrator, you can create a new user called OML User 2, for example, right? So that's not the focus right now. So let's go back here to our notebooks, right? And then let's check in with the lab 4, okay? Right, so with the data stores. So the idea, as I mentioned before, is working with data stores, you're going to be able to interact with Python, so you can store Python objects, right, and components there. So first things first, always import our libraries. You create a pandas data frame, right? And then you can load it. So for example, in this case, I'm going to do a sync. So I'll bring that table into a proxy object, right? But then I can also use scikit-learn. So I'm using scikit-learn and bringing a diabetes data set from scikit-learn here into my Python's memory, right? And I'm playing with that using pandas, right? Data frame. And then only after I concatenate those guys, right, in Python's memory itself, is that I'm pushing them to a database as these diabetes TMP, right? That's temporary proxy object. So what I'm doing now, I can play with the Boston, right, as well. And then I'm going to save the Python objects to the data store. So I can now say, use the save command here. I can save these objects. I can save the iris object. I can save the Boston TMP, right, into that component. So I can save the diabetes TMP table as well into the database, right? So I can do that process. So now I can save the iris object as well. So when you save all of these things into a data store, right, then you're able to run things like this. So I can actually run a GLM, right, regression, and then do a fit, and then I can do an OML DS dir, right? So when I do a dir, I can check a directory, right, of what is saved in my storage, right? And then at that point, you can continue on and grant privileges to other users and things along those lines, okay? So I won't continue this because of the time. Again, you guys can check that and have a further look into the components there, right? So we need to move on to running the using embedded Python execution. So embedded Python execution allows you to actually control and spawn different sessions of Python that the database can control. You have a database proxy objects. It's the same Python that we're running, but it's now controlled by the database that is running that session for you. So you can return from those sessions images, you can return tables, you can return data in a very flexible way, okay? So there are several functions that we can do eval, table apply, row apply, group apply, and index apply. These guys connect to the data and use the database and call that function in a different way, right? Row apply is row by row. Group apply, run this code once per section, right? Once per airport. Table apply, run the entire table at once as an input into my code, right? So that's the way you can execute these things. So for example, here I'm building a scikit-learn linear model, open source, completely open source scikit-learn linear model. And then I'm going to run and return that as a function. And now I'm going to run a group apply function into that model. And then I'm passing the data set, which is an Oracle database table proxy, right? And then I'm telling it what's the index, right? And I'm going to use it. I want to use two parallel processes, right? So that's basically what this is going to do for me, right? So it's going to execute that process in that way. So, and then we're going to use the Oracle Machine Learning Python script repository. So we have a data store and a script repository in the database where we can actually define our code, define our scripts, and then store them there to be able to execute that, right? So the script repository has all of these different functions. You can write stuff into the script and load and grant, same thing that we talked about before, right? So we can check real quick the lab 5. And then, so the lab 5 is basically building the model, the same thing we just did with that, but this time we're going to be building models, and then we're going to store the model, and then just as I mentioned in the slides, we're going to actually be executing those guys in parallel, right behind the scenes. So we got a do eval, we got the Python repository, so we got to import a few things. This time we're going to be using the linear model, if you remember from scikit-learn, right, that we said we wanted to use, so that we bring that over because we're going to be using it over here. So I'm building a linear model with scikit-learn, not using the in-database machine learning one, but a general one, right? The open source one. I can prove to you that it's working. I can see it predicts, so it works in Python itself. And now I can generate a scatter plot with it, and then we're going to basically build the model using embedded Python execution. So you build that, and then you can do a table apply, for example, right? So you build that entire function that does specifically that, and then now we can run that function. So the row apply function, right, is as we were mentioning, so you can do again, define the function, and then you can just say row apply. So I row apply the function to iris, and I want to execute that in chunks of 10 rows at a time, so that I can take advantage of parallelism. And then this is the output, right? And again, build one model per species using a group apply function and things like that, okay? So again, because we're running out of time, we're going to quickly check lab 6. I think this is one of the most exciting ones. Lab 6 is the AutoML one. So basically it's helping you when you're building models, instead of you trying to figure out and guess which model is best, to let you execute several models at the same time, right? And then identify those. So it not only does algorithm selection, right? But it does then, after that, it does feature selection for the algorithm that you identified. And then it will run automatic model tuning that's going to tune that specific model you built for that process, right? For the optimal process. So let's take a look at lab 6. I think this one is going to be fun to check out. So if you guys go back to your notebooks, here, the list of notebooks, and you're going to look lab 6, right? So lab 6, then, this time it's going to show you the basic AutoML introduction. We're going to import the libraries, right? So let's, I'm going to run this guy with you guys. So I'm going to import the libraries here. We're going to do OML sync function to create the OML data frame. And then we're going to check the table for wine, right? So we're going to check the wine data set here. So if I just press play here, right, on that guy, it runs. I can see that the file there. I'm going to run this set again of splitting the data, right, between the target and non-target, or X and Y. And now I'm going to do my automatic model selection, right? So I'm running an algorithm selection now. So I made it run. So by getting here, I say parallel to, I'm using the accuracy as a scoring metric. I have many. I'm using accuracy this time. I want to do a classification. And then I'm running that algorithm. So I'm going to tell it for wine algorithm, I'm going to use X and Y with K equals 4. K equals 4 in this case is going to tell me, okay, I'm going to show you the top 4 models, right, that were determined by the AutoML to be the best ones. You can use 2, you can use 7, you can use 1, right? That's not really there's no limit here in terms of how low you can go. You can probably go up to 8 or even more, but around 8, I would imagine, would be because then at that point you're getting at least one algorithm per one model per each algorithm, right? But the idea here is that this is going to run. It takes a few minutes to run these AutoML components. So when it comes back, it's going to tell you a list of models here that are the best ones. The same thing you're going to run then after here. When you take the best one from there, right, the best algorithm coming out of that, right, you want to input that algorithm specifically here. So you're going to say, you know, I'm going to run a feature selection now, and I'm going to base that feature selection, the reduced feature selection, using this one over here, right? This is the best algorithm out of the list of 4 that I had there, and I'm going to input that model here, and I'm going to run the reduce, right? So at that point, this process is going to reduce the algorithm, the algorithm features, right, used from the original, right, from 13 to 9. That's the idea, right? So originally I had 13 columns coming in, and now because of that, the algorithm, the process decided you actually only need this 9 features. And then after that, you're going to run the model tuning. So now with the reduced set of features, right, in the X, I'm going to then run that algorithm again for tuning. So now I'm going to get the best tuning possible out of that model, right? And then finally, I can check the hyperparameter results. This basically tells me what are the hyperparameters that were used by the algorithm to determine what's the best model, right? So AutoML is going to tell me what are the best parameters that I have possibly used there, right? So hopefully you guys catch a glimpse of this. I know it was quick, but the idea was to show you guys all these different features and capabilities. If you guys are feeling lucky, you guys might be able to say, you know what, I want the AutoML to do everything for me. So you can actually use model selection. Instead of doing algorithm selection, feature selection, and hyperparameter tuning, you can just say, you know what, just go model selection. Then we're going to do everything for you. All the 3 steps are going to be done for you automatically behind the scenes. And if you say how many algorithms you want back, this guy's going to tell you how many. So you get the best model. You get one model back. And that's the best model that we determined based on all of these components, right? So you're going to get the entire process done for you at once, okay? So So then I hope that was not too fast. I think we wanted to check one last poll with you guys, which was related to the types of work that you do, right? So which one of these types of aspects that you saw today you think might be useful, more useful for you on your work, right?
So as we wait for those results, Marcos, thanks for that great presentation and taking us through all those different notebooks. That was a lot to cover in 90 minutes, and the environment worked out for us.
Yeah, excellent. All right, so we see the results there. In database algorithms, it looks like it's a very interesting thing. AutoML is also coming up as a good good percentage, which is great. Excellent. So thank you. I guess what I wanted to say is, what we have accomplished. You guys saw all of these components today, from manipulating data transparency layer to database algorithms, the in-database ones, the data stores and Python objects, even open source Python models, and then OML for Pi, right? So where to go from here? I'll just want to leave you guys with a few. We have a few links. These links are also in the instructions that Sherry sent originally in the beginning. Maybe Sherry, you can send again the instructions PDF in the chat so that people can see it again. And then another way for you guys to join more sessions, we also have the Ask Tom office hour sessions. So we do have a lot of 101 sessions that we have done there. We have sessions every Tuesday. Coming up next week is actually a machine learning services hands-on lab. And then this morning, we had an Oracle process automation for real-time scoring using OML services as well. So then I'll say join us at our next TechCast, right? Thursday, June the 3rd. My friend Patrick Wheeler is going to be presenting introducing autonomous database tools. So that's a great way for you guys to learn more about those very useful tools even for data scientists. Those tools are incredibly valuable. Data loading, and data transformation tools are very cool. And then save the date, right, for the TechCast Days fall session on October 5 to 7. And they're going to be, again, those 3 days, right, looking at these presentations again of machine learning, spatial and graph analytics. So with that, I'd like to thank you guys again for your patience with all the, the processes and the environment and all the components. And then at any point, guys, feel free to ask questions and send your questions our way.
There was one question, Marcus, that came up, can we have access to the labs? And just wanted to remind everyone that, you've downloaded the labs and you can use those in any of the Always Free account or elsewhere, or of course through the LiveLabs. There's also a place on the web sort of documentation as well, where you can download the notebooks there too. So you have a few ways of getting access to those. But you can always reach out to us if you need access separately from either of those locations.
All right.
Okay, well, thank you all. And until next time, enjoy trying Python, and hopefully you'll continue working with the environment that you have set up now.